hier zitten ze ook, maar je moet achter de banners kijken.
Ja.
Bij het exit point.
Lekker daar een beetje links achter ons vast doen.
Nou.
Waar gaan we zitten?
Jeetje.
Ik hier in Nederland.
Hé? Jij knalt hier neer?
Ik ga gewoon ergens zitten.
Ja, laat maar. Ja.
Aan de andere kant zijn nog heel veel plekken. Oh ja, daarboven. Dat gaan we doen. Just having fun. Good, good.
Oh, aan die kant. Ja, dat is makkelijk.
Up here, up there.
Okay.
We're just waiting for a few more people to get into the venue and find a seat, and then we'll make a start.
Ja, leuk hè?
Ja, we gingen samen naar boven, dus ik ga ervan uit van wel.
Oké. Ja, dat gaan we doen.
Ja, alleen de Nick en de Robert.
Ja, we doen het. Ja. systems go? Kunnen we?
We'll give them one more minute. There is still a queue outside. I think this is Taylor Swift because the queue is so large.
Brit wil iets volgens mij. Nou, anders ga ik gewoon beginnen. En dan zeg ik wel dat Nick een Okay, take your seats, please. We're going to get started. Good morning. Goedemorgen. Welcome to Nlnog Day 2024. My name is Natalie Trenneman. I'm the chair of the Nlnog Association. Before we kick off the program, there are a few things I would like to tell you about Nlnog and about our venue today. This is the 11th Nlnog Day, and it's the 8th time that we're here in Podium Mosaic. As usual, all of our presentations will be here in the theater. All the food, the socializing, the drinks are downstairs, as well as the toilets. You can find them right behind the bar. And this year we organized for some extra space. We have the 2 studios of Podium Mosaic. They're a place you never saw before, and they're all the way after the toilets, after the staff rooms. There's 2 quite spacious rooms, so if you have to do some work or you want to maybe eat a bit more in private or have a more private discussion, you can go there as well. For lunch and dinner, we have a buffet, so if you informed us of any dietary requirements, you can take care of that yourself, or you can ask the staff from Podium Mosaic. Our friends from Event Infra took care of our Wi-Fi again this year, which of course is IPv6 enabled and does Rpki filtering. Yay. You can find the login details for the Wi-Fi, for the SSID on the doors. Anna Cox from the Red Dress Effect is our event organizer. And of course, our amazing audio-video crew, Sven and Denise, are sitting behind the curtain, making sure that the event is live-streamed, and that in a few weeks you can find all the presentations on YouTube to share. Talking about streaming, I would like to welcome our remote participants today. You can ask all your questions to the speakers through our IRC channel or through Discord. The information for that is on nlnog.net. And please mention Teun if you have a question for the speaker, because Teun will look after your questions. Teun is sitting there. And now I would like to announce some changes to the Nlnog board. Recently, Melchior Aalmans, our secretary, has decided to leave the Nlnog board. It's always sad to see a good board member leave, especially if it's also a dear friend. Melchior has served for 6 years, and he did a tremendous job as our treasurer, but overall as a board member, he did so many things. And we will miss him. Melchior, are you in the room? Did you conquer traffic? Can you come over for a second? because we have something for you. Kijk, en daar is Cas with the present. So, we know you do a lot of sports. This gentleman here ran the half marathon of Amsterdam just 2 days ago. So we were looking for a sports gadget that you didn't already have. Yeah, that was impossible. So we went for a completely different approach. We went something for a bit more relaxed, on the more relaxed side of things. You know I like wine. I know you like wine. It's not just wine. So, thanks for everything.
Thank you.
Thanks, Melchior. So then, there were Teun Vink, who took over the role of secretary, Niels Bakker, he's our treasurer, Niels Rijer, who is our vice chair, Cas de Reuver, who joined last year, and myself. But organizing an Nlnog day is a lot of work. We are not event organizers, we all have a day job. There's also tools that we have to look after, a lot of emails, 27 sponsors, by the way. So we're very, very happy that we found 2 new volunteers on the team. And they're sitting right in front of me. Can you come forward, Nick and Robert? Nick Bouwhuis en Robert van der Meulen. So you saw them today at the tickets already, and they will be doing a lot today. So yeah, thanks for joining us. You're free to go. Yeah. Okay. Of course, an Nlnog day would not be the same without our quiz and our amazing quizmasters, Peter van Dijk and Pieter Lexus. We will have a quiz this year, but we're going to do it a little bit different with the prizes. I'm already revealing what the prizes will be. The reason I'm doing that is because the winner gets to pick which prize the winner wants. The runner-up gets to pick second, and the third just gets the prize. So make sure you listen carefully. And by the way, the remote participants, you cannot join in the quiz. I'm sorry. So what we have for you this year is a Steam Deck, 1 terabyte OLED, an iFixit Repair Business Toolkit, the extensive edition, and a Pi KVM version 3. Yeah, so take some time to think which one you would like to win. And Nlnog has an excellent reputation for being a friendly and welcoming event, and we take great pride in that. Therefore, I would like to ask you to be your friendliest self today. I'm not going to read out our full code of conduct. You can find that on the website. But if you experience any unpleasant behavior or you witness any unpleasant behavior, do please report it to one of us on the board. And last but not least, there would not be an Nlnog event without our awesome and dedicated sponsors. An Nlnog Day is not a commercial event. There are no booths, we don't have sponsored talks. We definitely discourage sales activities today. But the tickets are free, the food and drinks are free, the live streaming is free. And for that, I cannot thank our sponsors enough. And for that, I'm going to mention them all, 27, in random order. Here we go. KPN, PowerDNS, SpeedIX, Duocast, i3d.net, M6, Arista, RETN, NLIX, Quansa, OpenBSD Amsterdam, LoanApp, Nokia, Smart Optics, LeaseWeb, Fusix Networks, 10IT, Fibering, NTT Data, Solid Optics, AVM, Nexpertise, Telesol, BIT, Genie Networks, Nexonic, And last but certainly not least, Air Traffic Control Netherlands. Thank you. And with that, I'm going to hand over first to Teun, before we move to Niels for the rest of the program, because Teun is going to give you a bit of an update of Nlnog tools.
Right, so good morning everyone. I'm going to give a short update on what we've been doing with the Nlnog ring mostly. So, to start off with some statistics, we've had a fair increase of ring nodes this year, net plus 88, given that a number of nodes left as well. I think we have well over 100 new nodes this year, which is, as you can see in the graph, more than we see an increase in the last couple of years. That's because new networks have joined, and also because a number of mostly large providers have added a lot of new nodes. Some even, well, in tens of nodes, so that's very nice to see. Got a new country. I failed to look up which one, but we're on 60 countries now. I'll show a graph of or a map where we are present now in one of our next slides, so you can see well, which spots we're still missing. And if you know someone who has presence there, please encourage them to join. Our looking glass has also grown. A number of new pairs. We hit the 200 million routes now on IPv4 and over 60 million on IPv6. So that's, well, it's a large route server by now. Well, here you have the graph of well, where we're present. Our home base, the Netherlands, is still the biggest country in the number of nodes we have, followed by the US and then Germany. You see that especially Africa is still a blind spot, and well, Middle East or Central East is still also, well, we could use a number of nodes there. So if you know someone, please encourage them to join. We did a few things new on the looking glass. One of them is the RFC 9234 support. What we do there, what the RFC defines how the relationship between two peers is, if they're like a provider and a customer, or if it's an IXP route server or anything. And that can help you to filter on what route you would expect from another network, and that can stop route leaks. So what we have done on the looking glass is that we can now show if a peer advertises those roles, because it's a new role, and also we can show the attributes, the OTC, the only to customer attribute. Unfortunately, not all router OS is supported yet. It's mostly supported in the open source routing software. Commercial vendors are hopefully working on it now, because we hope to see more implementations of this. We also have implemented the draft that Martin Pels wrote on how to formally define BGP communities. This draft explains how you can describe the meaning of your community definitions, and that can help a parser like the looking glass on how to interpret things. So you can tell, well, a certain community means that you prepend X times to a certain other peer, or something like that. Martin wrote some sample code for that, and we implemented that on the looking glass, so you can now also use a URL where you host your YAML file and use that to define your BGP communities. So I would encourage you to look up that RFC and to see if you can implement it. And it looks a bit like this. So on the left you see the definition, basically prepend to X times to specific peers on a specific continent. And in the black box you see a list of communities which we test. And you see that the parser that takes the definition on the left and parses the community list on the file. And well, then you see that 65001.2001 gets prepended one time to the North Americas, and 2003 gets prepended 3 times, and stuff like this. So this helps you to make a formal definition where you can explain how this is configured. RpNCC has written reference definitions for their ASs, so you can check those out if you want to see how they are written. One cool last thing to note is that recently a paper was published by Thomas Fiebig. He used the ring servers to do DNS measurements, and he measured a number of things. Co-location of DNS root servers, which in this case co-location means that several root servers share the same network, same endpoint. So basically, if you think that multiple root servers are geographically and network-definitely diverse, they eventually end up in the same place. And diversity is important for root servers. They measured integrity. And while doing that, they ran into a few fascinating things. And one of them is they observed bit flips. Bit flips is something that we've talked a lot about the last couple of months on IRC channel. And later today, Frank will be presenting on his work on, well, discovering and pinpointing bit flips and getting them fixed. So that presentation is really worth checking out. It's at the end of the day, just before the quiz. Well, the paper by Thomas is linked on the slides, and of course the slides will be available soon on the webpage. Well, that is what I had to tell you about the Nlnog ring. If you want to join the ring, if you have your own network, and you can offer a VM running Ubuntu 20.4, please contact us and we can see what we can do. Are there any questions about the ring or other tools?
Yeah, Teun, but you are supposed to gather the questions.
Yeah.
Yeah. Are there any questions for Teun?
Oh.
No? Okay. Well, then please make sure that we get lots more ring members, and Teun will be very happy, and so
absolutely.
are we. So thank you, Teun. Well, yeah, my name is Niels. For those who don't know me, I am the vice chair of Nlnog, and I will be the host for the remainder of the day. That means that I get to introduce all the speakers. The next one will be Yuri Palovi, I hope, from RETN. And maybe everyone can cast their mind back, because I think everybody here knows what WDM is and how it works. But maybe you can think back about the time when you first learned that this is a viable technology. Because I remember that I was working for an ISP in the beginning of this century. Yes, I'm very old. And we had a co-location customer, and the co-location customer had tons of capacity, but only a single dark fiber. And I thought, how do you do that? So I asked him. He said, you can do multiple colors of light over a single fiber pair. And I thought, no way. But yeah, there was a way. And this is not just the way, but there are still many more new ways being invented all the time. And this is what Yuri is here to talk about. The presentation should be ready here for you. You should take your stand here.
Yes, thank you.
And I would say give it up for Yuri and his brief history of WDM.
Yes. Yes, thank you very much for the introduction. You really saved me a couple minutes of presentation now. I really appreciate this. So my name is Yuri. I am a member of the DWDM operation team at RETN. I'm here definitely to speak about DWDM. Last year, Bob and Martijn gave us a presentation about subsea cables. And I thought to myself, all right, those guys are willing to listen something just beyond Rpki and IPv6. So yeah, here is DWDM. So yeah, as engineer, you could be tasked to bring multiple 10G, 100G circuits between two locations. And when you offer in your manager to lease additional fibers, he say, we need to keep NetX down. And purpose of DWDM is keeping your NetX, CapEx, all kind of expenses down. So, but before DWDM became a thing, there was a lot development is fiber optic communication in the second half of 20th century. So just from practical point of view, I would like to point out two events. So 1970, the first fibers, silica fibers that has attenuation limit less than 20 kilometers were implemented, and it just proves that low loss fibers could enable long distance communication. And second thing that in 1987 the EDFA amplifiers were invented. It will shape and shaped long-haul networks as we know today. So the concept of VDM itself, so VDM stands Waveform Division Multiplexing, DWDM stands for Dense Wavelength Division Multiplexing. So concept itself appears in 70s. So as mentioned before, it's simply mechanism technology that allows to combine different optical signals that has different wavelengths or colors of light into single fiber, just for further transmission over the system. So in the mid-90s, SDH/SONET was a way to go with long-haul networking, optical, and it's offering 2.5 gigabits per second speed. So, but there was issue. SDH allow you send only one single signal over the fiber pair, and each 100+ kilometers you will need very expensive digital regeneration. So in 1996, there was a breakthrough from Siena. They introduced the first commercially successful DWDM system that will have 16 channels of 2.5 gigabits. So in total, we'll have 40 gigabits. As you can see from the slide, it's a bit silly, but just to give you an impression how you can build 40 gigabits back in the days. So in the first example, you will use just pure SDH systems that require at least 16 pairs of fibers, a lot of color space along the road, and DWDM system that require much less space, only one single pair of fibers. So, as again, infrastructure cost, NetEx cost, operation cost, CapEx cost is all that we want to get as low as possible to enable transmission of a lot of bandwidth, because growing of internet today is just proving that it's only way to go. So, and let's take a look at just generic diagram of DWDM system. It has a few main components. First of all, is transponder. It's responsible for accepting customer client signals and change it, modulate, channelize it to the wavelength, color of light for further transmission. So we have multiplexers that we combine wavelengths signals from all transponders and send further to the fiber. So if the distance between two nodes is greater than, let's say, 100 kilometers, you will need amplifiers on the middle. And the amplifiers will simply amplify optical signal. And the far end, you have the multiplexer that do the same as multiplexer, but other way around, and transponders that will give back the client signals. So, and let's take a look at each element. And one of the elements I didn't mention, but is the fiber itself. So it's medium transmission. And originally in the 70s, technology allows use only 800 nanometers laser. As you can from graph, it have a terrible attenuation. And optical signals that travel from optical through the fibers will affect by linear and non-linear effects. Two main linear effects: attenuation, simple loss of power, and chromatic dispersion. And those two effects will also shape how networking will be developing. So in the mid-90s, technology allows us to use 1550 nanometer laser, and we got to the sweet spot of low attenuation. And in this case, for DWDM transmission, band 1530, 1565 nanometer was chosen. It's called C-band, and it's good not only because it has lowest attenuation, but also because first original EDFA amplifiers will cover this band to counter attenuation effect. It also has lowest non-linear effects that will be important further in development of the systems. So, as I mentioned, attenuation will counter by EDFA amplifiers. but how we can counter chromatic dispersion. And what is chromatic dispersion? Chromatic dispersion is simply cause the signal to spread along the traveling through the fiber, so as longer frequency will be travel faster than shorter, and in this case your signal spreading, and if you send several channels, they several signals, different wavelengths, in some points they spread so wide that they overlap each other. In the receiver end, you're just not able to detect the signal. So there was on the dates, originally there was a few ways how we can solve it. So luckily the manufacturer allows to build fibers with dispersion coefficient that we desire. So, and the easiest solution was just to build fibers with negative dispersion around 50 nanometers area, put them on spools and call dispersion compensation models. Then on your system, you just install them along the road to make sure that your total dispersion will be around 0, or at least you will try to do so. Other option was to build fibers, cables that will have 0 dispersion. At least at the beginning it was a great idea that you don't need DCMs that will bring your RTT higher 10–20%. So, but apparently 0 dispersion as bad, even worse than big dispersion, because due to 0 dispersion we have really strong nonlinear effects that will be affected DWDM transmission. It just doesn't work. So later G655 non-zero dispersion shifted fibers were introduced. They still have some level of dispersion that help to manage nonlinear effects. And on later stage, layer fibers were introduced that was widely popular and they built across the globe. And it was perfect for 10G modulation. But later, when the technology goes beyond 10G to 100G and more, the remaining nonlinear effects it has, those fibers will be affecting the coherent systems. So, as I mentioned before, we have erbium doped fiber application to counter the attenuation. Basically, amplifier has dope fibers that doped with erbium, and when a signal passes the amplification point, ions of erbium will amplify by signal. So it's really a nice invention, but there's one downside of this, that when the ions could spontaneously emit protons in all directions, and it will bring additional noise to the system. So it's, for DWDM system, it's very important to have big, great OCNR number, so signal to noise ratio. So, and the problem not that amplifier will add noise, they will be also amplify noise. So each step when you have amplification, you will bring more noise to the system. And in some point, you will receive the signals that you will not able to detect as well due to higher noise rate. So, and in 1999, Raman application was introduced to the market. So in this case, we have laser pumps that will pump fibers directly. So, and it don't bring any noise to the system. It's help us to reduce the noise level in DWDM system as well to extend the reach. So in some cases, when we need to pass really long distances, normally DWDM engine don't like to build long spans because there's longer spans that more gain you should have on your EDFI amplifiers, the more noise you will bring to the system. But in case of short subsea segments, there is no other way around just to use combination of Raman and EDFA amplification. So here is a segment between Netherlands and the UK, a distance 250 kilometers, and it's doable with Raman, combining Raman and EDFA amplification. So now let's take a view on multiplexing and multiplexing. Here, just to make it easier, I will combine in demux and multiplexing with add-drop multiplexers. So usually it's a bit kind of separate topics, but just make it easier. So as I told earlier, original DWDM system would have 16 channels on 2.5 gigabits, but around 1999, the 10G channels were introduced, so with 16 channels, we already will have 160 gigabits per fiber pair. So later development in 1999, again, we had 40 channels with space in 100 gigahertz, and 2005, we got to the point we have 80 channels with space in 50 gigahertz. And the last approach to increasing channels in this way was in 2007, we got the point 160 channels with 25 gigahertz spacing. The funniest part here is that it was just before coherent system were introduced, where we got to 100G super channels, and a lot of companies would be upgrading the 80 channel system to 160 channel systems, just to discover in a few years that you're not able to use your 160 channel system with 100G waves. And you had to downgrade back to old good 80 channel systems. So, the early ODMs have fixed wavelength grid, fixed signal wide, and manual airdrop only. So each channel will be assigned to dedicated physical port on ODMs. So, and of course, it's make operability of those systems a bit harder. So you have really plan ahead what you do, and if you miss some cross connect on the way, you have to send field engineers to fix it. So, and also such system was normally vendor log. So if you use one vendor A for your line system, MUX, demux, and amplification, then you have to use the same vendor for your transponders, for example. And I put this slide simply because I have to justify why I spent 2 hours to deassemble old ODM. But you also can check that it was still complex system, have a lot of components, and gain control, optic levels control, etc. So in 2005, we got to the point when first reconfigurable ODMs were introduced to the market. So now we can reconfigure the channel so we can connect to any airdrop, any channel we want. They were still fixed using fixed grid and fixed wide, but now it was more operable. But around 2010, or 2011, the first flex, so-called flex grid ODM were introduced. Now you do not depend to your planning in channel grid and wide. So you now can configurably change where you want your channel, put any point on the spectrum, make it as wide as you want or narrow as you want to suit your business and what type of modulation, what transponder you use, what distance reach you want to get. So, and it will be just limited at raw DM's granularity. So it's 12.5 from beginning, and then it's evolved to 3.1 to 5 gigahertz. So, and also Open RODM MSA was signed in 2016 between big vendors and carriers to allow operability between different platforms. So if you have now line system from vendor A, you can easily use vendor B for your transponders, for example. So, and we just show wavelength selective switch is cornerstone of any modern RODM system. It's basically a device that allow you route channels wavelength between line ports to any of the airdrops. It's allow you add or remove existing channels without any interference with the other channels. So it's allow things that allow you great flexibility on your network. So, and there is called CDC RODM network. So CDC stands for correless, directionless, and contentionless. So what it really mean? It's really mean when you have RODM node, you have multiple direction, so-called degree, and each degree will have its RODM unit. And what you do is just connect all your RODMs with each other and try to connect as many of your transponder to each of RODMs. So in this case, you just can reconfigure the network the way as you want. So you want the transponder 1 go to the east direction, you just could simply reconfigure. So transponder normally connect to ROADMs using the splitter with some amplification. So its idea is quite simple, but just because we have so powerful tool as VSS, we can really do this. So it's, of course, allow us build really flexible network, and we can create network with better SLA. Reliability was by building some protection mechanism that allow us switch optical circuits from one row to another row in case of some problem. For example, last year there was a massive flood around the Hamburg area, and our DWDM line between Frankfurt and Hamburg was affected by this flood, and we didn't have a clear ATR and no idea when it will be restored. But what we did, we just simply reconfigure all our circuits, move to another lines, and calmly wait for restoration. Last piece that I want to mention about line system. So originally we were stuck in the 4 terahertz C-band, but when technology improves, amplification technology and MUX-DeMUX technology, we are able to go to so-called extended C-band when we have 4.8 terahertz. But further time, market decides that it's not enough, and we need to additional band for DWDM. And it was a point, so-called L-band. It's additional 4 and 8 terahertz. So in total, we will have 9 and 6 terahertz. So it's just really great, but there's one catch. It's not because I make mistake on the slide, but that you will need 2 times of ROADM, 2 times of amplifiers, 2 times of transponder. So for C-band, you have your separate equipment. For L-band, you have another separate equipment. So, and it's just double all your capex, it make system more complex and less, I think, usable in operation way. So in our company, we decide for now it's better to stuck with extended C-band and try and invest those money from capex to building new roads to get better silent network. So an important part of any DWDM system is optical transport network. So before the first day of DWDM, it will always be paired with SDH SONET multiplexers to get, first of all, we need somehow wrap the customer signals to the DWDM network, and also to allow some monitoring, management, and etc. So in 2001, ITU-T have introduced OTN standards to make sure that all vendors will at least try to follow it to make networks interoperability. So OTN, it allows us, first of all, transparently transport almost any kind of customer signal payload. So we can transfer Ethernet, SDH, SONET, and other. So it also incorporates very powerful tools that called forward error correction, FEC. So it's not only allow you to detect the errors, but also fix error on the receiver end, and that will extend reach and performance of the system. So only thing that you need to pay is around 20% of rate data will be spent on the FEC. So also OTN allow you multiplexing lower level signals to higher order. So you can do from ODU 0 go directly to ODU 4, or from ODU 2 go to ODU 4 directly as well. So it's make network really flexible when you can use less carrier, less wavelength to combine different type of traffic on your network. Also, effectively, normally you will build second network on top of your DW network. Its topology could be different of your DW network to suit your business approach, for example. And also, as you have, this will be pre-built digital capacity. Service provisioning, service routing, different kind of protection mechanisms, much simpler to organize here than on lower DWDM level. So here I would like to just show you that there are 2 approaches on building OTN network. That one more classic and centralized OTN. It's normally very big chassis, OTN chassis, half rack or full rack, that you have OTN switch fabric and a lot space for your line cards or trip cards. So the way you really also flexible can create digital cross connects, digital sockets, different type of adaptation, very flexible things. One downside of this, it requires a lot of space, a lot of power. So this is why we now see that vendors try to shift market to the so-called OTN on blade, when OTN will be only on transponder size. So there will be, of course, much less features, less much granularity, but it's cheaper and more scalable in the longer run, because now we see that for 400G, for example, it's no really OTN fabric. So, and the last key piece is transponder. So what does transponder do? First of all, it should accept client signal, convert it from optical to digital form, apply OTN mapping and FAC, and also channelize the second service with some kind of modulation for further transmission in the network. So for original 2.5 and 10 gigabit channels, we will use amplitude modulation, or as you can know it, on-off keying. So it's very simple. When you have 1, you send light. When you have 0, you don't send light. So it's very simple, easy, and cheap to build, but there one catch, because you will need 2.5 times your spectrum in gigahertz than bitrate. So if you have 10G, it will require 25 gigahertz spectrum. But if you want to do 100G, you will need 250 gigahertz. It's quite a lot. And likely we can detect not only a change in amplitude, but also phase. So phase shift keying modulation was introduced in 2009, I think, to the market. So the easiest example is BPSK. So we can use 2 shift of phase and again send 0 or 1. So effectively we have the same symbol, bit per symbol, that amplitude modulation. But if we can detect phase shifting more precisely, we can use QPSK. 4 bit, we have 2 bits per symbol, so we're doubling our capacity. Using phase shifting and higher order modulation became possible in 2010 when so-called coherent technology became available on market. So it's use coherent receiver when we have oscillated signal on the receiver ends that help us really detect the changes in the signals that we are receiving. And also the digital signal processing and very fast analog to digit converter. So also coherent technology allows us to use polarization modulation. So fiber itself allows to send 2 orthogonal waves. So, and with using polarization modulation, we can split our signal to 2 polarization and send effectively not 2 bits, but 4 bits for QPSK. So in this way, we doubling our capacity. So, and to get more capacity, we need higher order modulation. Example is a constellation diagrams for higher order modulation, and as you can see, 60 QAM have 6 bits per symbol, and QPSK have only 2 bits per symbol. So we win 3 times capacity. But there is just great, but there one catch. Because we have so many constellation points, the signal now more affected for noise and non-linear effects. Self-phase modulation, for mix modulation, and etc. So here example for QPSK, 100G could travel around 4,000 kilometers. At the same time, 64 QAM 300G could travel only 250 kilometers. So we reach the point where spectral efficiency is really high. But the last thing that you want is build really expensive digital regeneration every 250 kilometers. So is it, but I still won't have those juicy 800G, 1200G, 1600G super channel on my network. What vendor can do and what they did? They just simply increase the baud rate. So With increasing baud rate, we can get higher bandwidth, but we don't get to the higher spectral efficiency on our network. So here, example, you can send 200G and 400G using the same modulation technique with different baud rate. And in general, it's the easiest, cheapest way how we can get more capacity. But again, it's not improve our spectral efficiency. And the way to improve it, it's using probabilistic constellation shaping. So in the technique, it's allowed to choose constellation points that we will send more often, and to assign them symbols that you need to send more often. So in this way, you will use mostly the constellation points that closer to the center, that need less power, so will be affected less with non-linear effects. So better performance, better reach, very granular approach, and we see that a lot of vendors use it now, so you can change your G-baud rate very flexible, you can change your modulation very flexible to get to the point where each DWDM system has its own, or scenario, its own performance. So you really can granularly choose what kind of modulation, what kind of G-bauds will suit your network to get the better performance. And here, example, why spectral efficiency not always a key. So this year, Ratten began migration for 400G band links, and we have two options how we can proceed with. We can install 800G transponders, or we can use QSFP DD-ZR+. So that install it directly in the router, using also coherent technique, but it has spectral efficiency on the ZR+ is 25% less than of transponders. If you have 100G, it's not a big deal, but if you need to deploy several terabits, it could be a crucial case. As always, you need to compare advantages and disadvantages. In this case, we have really huge capex saving and NetX caller space saving as well. So clearly that we choose 400G ZR+ for our upgrade. And this slide just overview how total capacity of DWDM lines changing. So first part is just because we're increasing number of the channels from 16 to 160. Then we got to coherent technologies that allow us to first use 40G waves, 100G waves, and beyond. And around 2010, C plus L band became widely available, and now you even could put even more capacity in your network. And this graph just to show you that we will see even more changes in DWDM in recent following years, because the amount of international traffic is growing like crazy. And it just shows how also line ports rate evolve during future time. Thank you. Hope you enjoy my presentation. Please let me know if you have any question.
Thank you very much for your presentation, Yuri. I think this is amazing technology, because if you think about what happens if only one bit flips, and then you see all this, man, it's amazing. We have time for one important question, if there is one. Otherwise, we thank you again, Yuri, for your presentation, and hope to see you next time.
Thank you.
I know network engineers who have said, it is my dream to one day work at M6. Now, I have good news for these network engineers, because I have someone on the schedule today who will tell us exactly how you do that. And judging from his title, I think you start at the service desk. And judging from his presentation, you also have to drink something, but I think that will become clear. Leroy de Vos is going to tell us about his career from service desk to the M6 NOC. Take it away, Leroy.
Thank you. Hi. Yes, I'm gonna... Does it work? Yes. I'm going to take you to the journey I went through of becoming a network engineer. Currently, I'm working as a network engineer at AM6, but this journey will be how I got there in the early years. So starting after high school, at this time it still amazes me that some kids at 17 know what they want to do for the rest of their life. This young buck didn't have a clue. He didn't know what he wanted to do for the next 40, 50 years of his career. So this resulted in me doing all sorts of jobs. I worked at a restaurant, I did some construction work, I even worked at a game store for 2 years, which was amazing. Selling, talking and playing games for 2 years, that was great. But between all those jobs, I always seemed to return to the customer support of ISPs, and then usually grew to the technical support, helping with email, the home modems, and later IPTV. So when at the end of my 20s, the beers became more expensive and the holidays became more expensive, I needed to do something of a career. At the time I was working at customer support of KPN at the second line, and a colleague of mine introduced me to a CCNA study book, the beginner certificate for most network engineers. And when I started studying and I used GNS3 and made my first ping work, then I was sold. I knew this was a fun thing to do. It is most of the time. But yeah, this introduced me to the world of networking. This got me a promotion to the service desk NOC of KPN there. While I wasn't doing the full hands-on work in the networks, I did sit next to the people that did. They helped me out in my studies. I could ask them questions, see what they were doing. Unfortunately, KPN moved to a different location that was a bit too far for me to travel. So this resulted me in finding a different job. So with my CCNA in my pocket and having seen some networking, I thought, well, let's become a junior network engineer. Apparently, having the lack of proper real-life experience did hinder me a bit in the interviews, and this, in the end, ended me up at Kwanza. While I went for the engineering job, they didn't have that job available for me, also compared to my skill level. But they were building a new 24/7 NOC, which they promised would be more technical, and you got a bit of hands-on experience in that job. And they delivered on that. It was my first introduction to an IXP, as they do the 24/7 first-line support for AM6. It introduced me to the first optical network with the customer SurfNet that they have. And they have their own individual customers, which all networks always have their own thing and are different. It was my first time working in shifts, which is a bit of getting used to if you haven't done it. I did my first firmware upgrade, which was scary because waiting 10 minutes for a device to come back, the first time is always scary. And I educated some people in the team and saw them grow to in the job that I did. So after 3 years, I got the opportunity to become an engineer, a network engineer at Kwanza. So when I got to the promotion, I got my first experience with real hands-on. And from the study books and everything you learn in the books, it's different when you do it in real life. My study guides were 4 routers, 4 switches. You knew what you were doing. There was no clutter in it. And all of a sudden you have dark fibers, you have firewalls, you have servers. Things you didn't touch. So after a year, I kind of struggled. It was hard. I didn't feel like I learned as much as I should. I grow as much as I should. So this made me decide to leave Kwanza and go to a different company that was smaller, that was just doing routing and switching with a little bit of firewalls in it. At the time, it felt like taking a step back. I thought I failed a bit because, I couldn't make it work. But in the end, it seemed to be a sidestep. This really helped me to solidify the basis of the knowledge that I studied for. It was simpler, and I really got a hang of the knowledge that I had, and I could put it in practice. Unfortunately, the company at the time where I worked with, their main business was in retail. And yeah, when the coronavirus hit, this meant that the work was drying up. So unfortunately, I was let go after a year. And yeah, then was the question, where do I go now? Do I return to Kwanza now with the knowledge that I have? Or do I go for a new opportunity? And that's when I was hired by AMSIX. Because I knew them from Kwanza, I knew the manager, Kostas. And yeah, after a few good talks, I got hired at AMSIX. And yeah, I got to say, if you have friends that don't work in IT and you say you work at AMSIX, it's like, okay, you got a job. But when you talk to your IT friends, it's like, oh my God, you're working at AMSIX? Really? You can really mess some things up. It's like, yeah, you can. So yeah, getting the first year, getting into the operations, it's a lot of reading. It's going over the wiki. It really is a different kind of network than in any of the study books that I've read, but very challenging. And yeah, more and more I got into the day-to-day operations, which, yeah, you run into new things. I could give an entire presentation on the day-to-day at an IXP. But for now, I will highlight some of the projects I've been doing. Yeah, don't look at the left picture. It was my first time cabling, going remote. This was in Chicago. Here I replaced our DCI solution with our partner Smart Optics. Yeah, ever since my field engineers have educated me properly on how to cable and make it look nice instead of the picture at the left. Having worked at Kwanza and they are doing our 24/7 support, I'm able to, yeah, of course, put that knowledge back to Kwanza. Here I was educating a new group of people that were hired at Kwanza for doing our first line support. So yeah, this once again shows how small the world of IT usually is. And while I was not fully a part of the first migration, I was present as I was on call that day. And I did it for the experience, definitely not for the free pizza that was offered. But yeah, you see quite a few very happy engineers here when we finished our first Juniper migration last year, which was amazing to do. And of course, then I did my own Juniper migration, which was, by Tim, who wrote a blog post of it, dubbed the Monster Project. Here we used to operate Sarah and Nikev as one big supersite location. And for the migration of Juniper, we decided to split those locations up again and make them their own location. So yeah, you can see this as a double migration in the same time that we usually do one. I could also do an entire presentation on this project, but I highly recommend go read the blog post posted there, written by my colleague Tim, which will go a bit more in depth in how this monster project came to be and how we finished it. Then one of the fun parts of working at AMSIX is that you get to attend events like Nlnog, but also abroad. You go to the Euro IXs, the Nanogs, which really is fun to do. You get to interact with the customers, partners, and colleagues working in the same environment. So with all these projects and milestones, is it also roses and sunshine? Well, no, not always. My first big outage was in Chicago, which prompted the replacement of our DCI solution. And yeah, this was my first 24-hour shift. It was in Chicago, remote time, on a network we weren't fully aware of. And yeah, this resulted in a 24-hour shift, getting partners to work, getting the remote hands to work. And yeah, I did it in conjunction with my layer 3 at the time, who's here as well, Tiago. And I got to say, working 24 hours is very different than gaming for 24 hours. Your brain really gets mushed up, and thinking clear, you really need a second pair of eyes, and preferably a third. One of the other fun nights that I had with another colleague of mine, Stavro, is when a line card failed. That was during the night. We went to the office, got a new line card, went to the data center. We got the wrong line card. As you can see, they kind of look alike. So we went back to the office, got the line card, made sure we had the right one, went to the DC, was the wrong one again. So this resulted us in driving between data center and the office 2 times at night, finishing at 7 o'clock in the morning. So yeah, that was a really fun night. And of course, when you start working at an IXP, when you hear about an IXP, they warn you about loops. Loops are the death of our platform. When you start, you get warned about it, you get examples, you know it, you try to prevent it. Unfortunately, it happened to me. In the early morning, I was asked to test the customer port. We placed a loop on the port. I removed all the config. I had a colleague controlling that, I moved all the config, but we didn't remove the port from the VLAN. So, causing a loop, we found out within 30 seconds. Within 30 seconds, it was mitigated. And what is the impact of a 30-second loop on our platform? Well, as you can see, well over 1.5 terabyte of traffic lost within 30 seconds. It really is the death of our network, causing a loop on our platform. So after all this, once again, am I now a... Well, they made a party of it. Am I now a network engineer? Talking to colleagues and peers alike, it's, when you work hard, you make mistakes, you own your mistakes, and you learn from them, then yes, you're on the road to become a network engineer. So this is my story of how I got here.
Well, thank you, Leroy. That was a very recognizable story from parts like making loops, having wrong line cards, but also the part about taking a step back to think about what it is that you actually want. And of course, the drinking beer part.
Of course, it's needed.
If there is something that people would need to take away from your presentation, like people who may think, am I on the right path? Is my career going well? What is the thing that you would advise?
Make use of the colleagues that you have if you're in the job. If you're not yet in the job but aspiring to, do the hands-on as quickly as possible. I really thought at Kwanzaa, after 3 years, I got my CCNP route and I really knew my stuff, and then you get into the dirt and it's like, you almost know nothing. It's so different when you're doing it real life, when you actually log into the devices instead of reading it and practicing it. And and make use of your peers and your colleagues. Ask questions. Make sure for your senior that you don't ask the same question twice. Write it down, learn from it, and practice it. Use your environment. Use your environment.
I'm happy I asked that question. I see there is another question over there for Leroy. No? Go ahead.
Rob from LONAP, now another internet exchange, which I accidentally ended up working for. This sounds all very familiar because, I applied to work for this thing called Links about 23 years ago. And it's exactly the same, what you've just said now, as what happened when I started working. And I think, well, we didn't particularly have a plan for my career. I didn't know how this was going to work. A lot of people, and AM6, we were exchanging stories back then with AM6, these foundry switches, these loops. We could tell you all about that and all the horror stories. And it's great that we can do that. And we love to share the horror stories. But there's no particular plan. I was thinking, will I ever get good at this? Will I ever stop breaking stuff? Probably not. No. But we do, and I love this community because it's a very open thing. We love to get up and share the quite embarrassing stories about how we broke it and how you don't want to do it. And I don't think there's very many other industries where people will get up and openly say, oops, oops, in front of everybody else. But we do, we love it, and we learn from it. And it's brilliant. We do need to get more people into this industry as a career, and it's a thing you can do. It works. I'm not getting any younger, and I'm seeing the same faces in this room as I was seeing back, in 20-something years ago. So, what would you suggest to get more young people, new people into it?
Yeah, it's difficult. It's get people in school to attend these kind of events. Get them to a Euro IX, make some places for that. Get them to the NOGs, the Nlnogs, the different NOGs in over the world. Get them to the events, get them talking, get them in contact with the engineers doing the work. And telling the horror stories was also the fun sides. When you finish a migration, it feels awesome. When you solve an issue that you've been working on for 2 hours at 2 o'clock at night, it feels so good when you solve it and you did it yourself. So get them involved, get them in the community. One of the things that I learned at AMSIX, like I said, the events are amazing to go to, is the community is awesome. But you don't get in the community if you're not in the space. So yeah, make space for high schoolers, for MBO, HBO, university. Make 10 tickets, invite them, see if there's interest, and expand on that, and see how that can grow. That would be my thing.
Okay, one short question, Rinse.
Oh, I will make it short. It was a very good story, very recognizable. Just a simple question. Do you have any dreams left? Now you're working at AMSIX. Maybe that's the top of it, or is there still something?
I have honestly asked myself that question because 10 years ago when I did my CCNA, my goal was to get my P certificate from Cisco, because yeah, routing and switching P is really high level still. Accomplished that. Second goal was get into a renowned company and do fun stuff. I've done that. So yeah, now it's expanding on it. So going to more events. We at AMSIX are now spreading internationally. So yeah, getting involved with up and coming regions like Africa and Asia. That currently is my goal I've set. Yeah, to bring this community more broader, and thankfully AMSIX provides the opportunity to do that. So, thank you. Yeah.
Thank you again, Leroy.
Yes.
And with that, we go into the coffee break, which we will take until 11:10. We will resume here at 11:10. Can you all please take your seats again? Can you all quickly take your seats? Okay, let's start again. Welcome back. For the next part of the day, after this coffee break, we have one big item on the agenda, and that is event networking. When you are at an event like today, there is Wi-Fi. It is awfully fast, at least it should be. There's IPv6 and everything. This is all arranged by Event Infra. If you go to a RIPE meeting, there is a RIPE meeting network, and it also works very, very well. Now, and if you ever visited Cisco Live, well, that's also something. Actually, it was Andre from the RIPE NCC who first talked to us and said, hey, I may want to present something about the RIPE meeting network. And then we thought, hey, but that's nice, because we also have a meeting network. So let's have Arjan present as well. And then, two is not large enough crowd yet. So we also asked Andrew, who worked for Cisco, to tell us a little bit about what he does with event networking. So the idea is as follows. Each of the three guys will present for about 15 minutes about their event network. And then all three will join us again on stage for a panel discussion where you can ask about your event networks and discuss pros and cons among them about how they do their event networking and what they should or could have learned from each other. I don't know. First on the agenda is Andre. So I would say take it away and tell us about the RIPE meeting network.
Okay, thank you very much. Yes, this is me. My name is Ondřej Caletka. I work for RIPE NCC, and we have this meeting that we are organizing for our community called RIPE Meeting every 6 months. The next one is actually next week in Prague. So you are all welcome, unless if you are not registered yet. There are about 600 people on such an event, if you were not there yet. But I recognize lots of familiar faces here, so I guess I don't have to go through this too much. The thing is, we bring our network there, and it's so we do it in a way that we have our own AS number, 2121, and our own bunch of IPv4 addresses. Well, bunch, let's say we are quite rich regarding this in today's prices. And also of course, IPv6 prefix, and we basically bring the network to the location, connect it to local connectivity sponsor, and start announcing it. So it's like a real ISP, except that it moves every 6 months to different location. And with that, we have some issues observed, and you probably were observing it as well. The first thing is geolocation, because internet is not just internet. It's always like services are interested in where you are located. There are two basic types of geolocation. The first one is like BSS ID or MAC address of the access point based geolocation. And this was something that like was a big issue back in like 10 years ago, and it sort of disappeared. So I guess Google and Apple made some changes in their system, or maybe they just removed our network from it. But I have this interesting map from my Google location history where I made it in 1 hour from Amsterdam to Warsaw to Athens in 2014. So this is how you did, because somehow my phone was trusting the most the MAC address of the access point that is connected was the highest probability geolocation source. Yeah, and usually in the venues you don't have GPS to get some other data. The other thing is IP-based geolocation. This is much more prevalent because BSS-ID-based geolocation is only, this is only accessible to people like Google or Apple, maybe Microsoft, who are taking care of the devices, but every service provider out there who is showing advertisements to you needs to know where you are, because they can target advertisements, and for that they need geolocation. They use this IP-based geolocation. The problem is that there is no one geolocation. It's just like privately curated lists of different commercial providers that are creating their own list and selling it to people. We, together with IETF, network operators, and also other similar events, have established some deal with Google, and we are publishing a CSV list in Google saying these IP addresses are in this location now. And this CSV list became later RFC 8805. So now it's like the standardized way of publishing geofeed. Which we do as well. We just the file is still called google.csv because, but it's just like RFC 8805 standard. It works. With this becoming a standard, the geolocation provider started to consuming these files much more often, but we still have to tell them. So there is also another RFC saying that you can discover it using Whois, where you basically put in your RIPE database. For instance, you put the attribute with the link to this to this list. This does not really work. At least we haven't found it. So what we have instead is that we have a list of 7 geolocation providers, and between each RIPE meeting we email all of them saying, "Hey, our network is now going to be in Prague. Can you please update your database that this address range is now in Prague? And by the way, we are publishing this feed, so if you would like to consume it, it would be great." And out of the 7, 5 are already consuming the feed, so in theory we don't have to ask them again. We just still poke them, "Hey, make sure to read it again." But 2 of them are still like processing our manual updates every 6 months, so that's a little bit sad story. How the network looks like? Well, it's made to be portable, so we are, and we ended up over the years, the network changing a lot, but the current state is basically that we are running everything from layer 3 above is virtualized in a Linux host that is running inside VMware on a super server, which is those small black boxes on top of that rack on the picture. Just quite nice and small boxes that you can carry even in your carry-on luggage if it's necessary, so that's quite handy. And then the other networking gear we have basically switches, and we only use them as a layer 2 devices. We have some Junipers, we have some small Zyxel switches that you might see lying around if we need to, put switches somewhere in the middle of the meeting room. And we have those core switches made by MikroTik, which are this super cheap 10 gig 4-port switches. And then we have access points. We are using access points from Ubiquiti, Unify, access points quite old now. I think it was 2017. Most of them were bought. So they are supporting only 801.11ac And yeah, hopefully we will replace them to something newer. But in the end, yeah, like not a big deal. This is how we tested them when the COVID break was over, and we was not sure whether it still works after 2 years being stored in the storage. So we plugged all of them. So if you want more Wi-Fi, this is the most Wi-Fi you can get probably. It's like 50 access points. As I said, the whole like infrastructure of the network is virtualized. It's running on Linux servers inside VMware, and it's running open source. So we have routers running Bird, we have firewalls using NF tables, we have resolvers with node resolver or bind, we have load balancers, we have DHCP servers Kia, we have NAT64, Joule, and we have stats using CollectD, InfluxDB, Grafana, and everything is deployed using Ansible. So basically, most open source software that is for network, we use just like the simplest way possible, let's say. This is how the logical network topology looks like. There's not a big surprise. On the right-hand side, there's the host network. We have 2 routers. Then we have some kind of backbone network where the NAT64 lives. And there's firewall, which is also like default gateway for all the networks. In the end, it's like 8 different networks that we are serving in play. So it's not only the public network that you connect to, which is on that access points, but also like various service networks with different firewall rules. And there's also this a little bit over-engineered DNS resolver cluster, which I really like the way it works, because there's just one segment with 4 resolvers and 2 load balancers. The load balancers are working in the direct routing mode, so basically they are only bouncing the incoming traffic to one of the workers, and then the worker is talking directly the other way without reaching through load balancers. That's quite interesting setup. Also, an interesting thing about this network is that we, since RIPE 85, we are running a main network as something called IPv6 mostly. What is that? It's basically a dual stack network. Well, first of all, I talked about this at this particular event 2 years ago, so maybe you remember. Yeah, it's basically a dual stack network that also supports NAT64, DNS64, Pref64. That means the devices don't have to use necessarily IPv4 if they don't need to, and they don't. Actually, 70% of devices are running v6 only on our network and not using v4, and only the last 30%, let's say, are still running v4, and for them we provide v4, but we provide much less of it. The thing is, it requires perfectly working IPv6 as well as NAT64, DNS64. So this might be a bit challenging, because in normal dual stack network, you see that all the problems with v6 are just masked by happy eyeballs. With this, let me show you some issues that we have with NAT64. So we use the well-known NAT64 prefix, and we use pool of 256 addresses. Everything works, except that some VOD platform like NOS/NL or EVC line says that the video doesn't play, everything works. And the browser console says 403 forbidden when the data should be coming. So we see, from the network engineer perspective, this is application layer issue, so just if there is 403 error, then we don't care. Well, we do care, because we want our eyeballs to be happy, and so we have to figure out what's the issue here. The issue is that this is how the video-on-demand platform usually works. First, your client is getting some token from some token server, and then with the token, you go to the CDN server for actual video data. And with some platforms, like NOS/NL, the token is actually tied to your IPv4 address that you are talking to the server, which requires you not to change your IPv4 address between talking to the token server and talking to the CDN server, which unfortunately is something that happens by default with Joule, because it just hashes destination IP address and destination port and source IP address in order to figure out which IPv4 address from the pool will be taken. Fortunately, this can be fixed by a global option called fargs, so this is how we fix this issue. I also complained in the mailing list, and the author came with this Ondřej Cajtka hashing algorithm, which I really like. That's why I put it here, which basically is a way where the IPv4 address will get sticky and stay the same for one host. So this should prevent this thing. Unfortunately, this thing was not merged in the production, so it's still in the branch and it's not part of the Joule. So if you are deploying Joule as NAT64, you probably have to tweak the fargs to fix the issues with NOS. Another part, I'm already quite long, but another thing that I would like to point here is that setting up Linux router for IPv6 made me go and read RFC 4861 about IPv6 neighbor advertisement, which I didn't really need before because it's just like ARP except for IPv6 and it uses multicast, and the most issue with it are issues with multicast. But then I figured out that in neighbor advertisement, there's this flag called R, which is set when the neighbor is actually router, and it's not set when the neighbor is not a router. And this is used for detection whether router changes their role to host. And what happens? So you just set up a new network, it works nicely, and then you attach your Linux host and it works nicely, it works forever, and then you attach your macOS, it works nicely for 6 seconds, and then it stops. And then it stops and the default gateway will disappear from your routing table. And then you reconnect to the network and it works again for 6 seconds. Well, yeah, it turns out that 6 seconds is the time from receiving the root advertisement till the macOS will go and check with neighbor discovery whether the default gateway is still there. And if the default gateway responds with R set to 0, let's say, oh, this is not a router anymore, let's remove it from the routing table. So actually macOS is doing the right thing and Linux is just ignoring it. The question is, what makes a Linux router respond with router flag set to 0? And it turned out this is the only feature of the sysctl forwarding switch that is available on Linux per interface. So you have like net IPv6 conf ETH0 forwarding, and this doesn't do anything except for the R flag, because the forwarding is global switch on Linux. So this is something that we discovered. It was quite fun, and it was easy to fix, and now it's fixed in Network Manager, so it shouldn't happen anymore. But good to know, new thing to learn. Another new thing to learn is that, yeah, if you used to run Network Manager and you had a full BGP feed in your routing table, Network Manager was eating the whole CPU just by processing all the netlink messages. I was complaining about it at Raspberry meeting, and there was a guy in the audience saying, hey, we actually reported this to Red Hat because we are paying customers. And then Red Hat fixed it, and they fixed it for everybody, and now it's fixed, so no problem anymore. Another issue is that if you run a network that is like public, you will get those internet-wide scans. And if most of the IPv4 addresses are not in use, they are still like, you know, somebody is probing them and they are just creating ARP messages asking whether there is somebody with that address. And the problem is that Linux doesn't have negative cache for this. So it's, the network is like full of broadcast of ARP. And especially in Wi-Fi network, you really don't want broadcasts, because broadcasts are like 1,000 times slower than unicasts. So even though the efficient bitrate here is like 84 kilobits, you can say that's nothing. The equivalent airtime is maybe 84 megabits, and that's something already like different. There's easy solution to that, and that's part of ipro2, which is the package every single Linux distribution has. Rpd is a user space implementation of ARP that has negative cache and stores the ARP cache on disk. So if you run it, in case of my empty network, when I tried it, running Rpd will lower down the amount of broadcast 30 times. I think that's worth running a simple utility. Yeah, and the last thing I have here is about Wi-Fi. We use Unify. We are quite happy with it. It works nicely with V6, even though Unify is trying to pretend that they don't know anything about it. we are running most of the SSIDs 5 gigahertz only. We have special legacy SSID that is 2.4 gigahertz, and we change name every single event. So in order to make people force, you know, if they have configured the right network, it will stay and it will work always. But if they want to use 2.4 gigahertz, they have to configure it every time again. And there's a feature in Unify called multicast and broadcast control. And funny thing about this feature is that it kills IPv6 neighbor discovery protocol. So we are using it as a sort of array guard. So if somebody wanted to like break the network by sending router advertisements, they will just not be propagated by the means of this filtering. So it's a side effect of the feature that like Unify probably didn't mention like this. And we have to allow list basically MAC addresses that are allowed to send neighbor discovery protocol, which have to be all the wired hosts. Yeah, and I lost the numbers here, so you just see now nice pie charts without any annotations. That's funny. But yeah, you can see that the big amount is 5 gigahertz. On the first chart is a 5 gigahertz host, and the second chart is IPv6 only host, and that's everything from me. So I think questions will be probably at the end of the...
Yeah, we will do that at the end. So if you have questions for Andre, then please remember them until the panel will be at this table. But if you have applause for Andre, you can do it now. So then on the presentation laptop, we will quickly change to Arjan's presentation. And that's, I think it should be just the next slide. Yeah. Oh, okay. So one thing I noted about Andre's presentation was lots of servers that are involved in keeping this network running. And I know when Arjan and his team were here last night, there were no servers involved. No. So I'm curious, how do you do this?
Okay.
Just take it away.
Hey, my name is Arjan, and today I will tell a little bit about networking at hacker festivals. For my day job, I'm working at I2D.net, and as a volunteer, I'm involved with the organizations Event Infra and BitLayer. This is the hackerspace in Amersfoort. And besides that, I'm also helping out in various event Nlogs, such as the hacker festivals I will talk about. And as you can see, I like to climb things, but the story with the Dixie will become a little bit more clear later on in the presentation. Event Infra is a non-profit that supports various non-profit / community-run events and festivals. It started out in 2015 as an independent entity to be able to share equipment and infrastructure between events. So as opposed as equipment that might be sitting in storage for over a year collecting dust, it can now actually be shared across multiple events. And in the past, there also have been a number of events that had to exclusively rely on demo pools from networking vendors, and so Event Infra is a way to reduce the risk of equipment not being available for your event. Event Infra is, loans both equipment to events, but is also able to provide IP connectivity. And we do this through our AS 64404, and we have a point of presence in NICHEV. Good to note is that Event Infra does not actually operate an on-site network, and this is usually done by a team of volunteers. Event Infra purely runs off donations. It can be either in money or equipment, and donating equipment is quite a good way to give your equipment a second life. So get in touch if you have anything that is old or you cannot use anymore. And any equipment that at some point we don't use anymore, we will try to give it away back to the community. The Event Infra stock over the years has maybe gotten a little bit out of hand because we have over 500 access points in stock, 400 switches, 15,000 ports, 26 kilometers of fiber, and this is all adding down to about 7,000 kilos worth of stuff that is sitting in our storage facility. So I hope the floor load in our building is okay. But Eventinfra is supporting a number of hacker festivals in Europe. The most well-known ones are the Chaos Communication Camp in Germany. There's the Dutch hacker camps, with the last installments being SHA 2017, MCH 2022. And next year there will be Y 2025, held at Geesmer Ambacht, north of Alkmaar. And in the UK, EMF, or electromagnetic field, is being organized. These are all multi-day, non-profit, outdoor hacker camps, festivals and conferences with up to 7,000 attendees. There are presentations at big stages. A pretty big difference between the larger music festivals and these kind of festivals is that there are all of the camping is mixed. So while at these music festivals there's a hard split between camping and all of the performances. At the hacker camps there are also lots of art installations, and they really shine during the night. Here at the bottom right, I'm not sure if that's visible, but it's a picture taken from a drone that was hovering over the CCC camp in 2023. On the top right is a picture, aerial picture from SHA 2017 when it was held in Zeewolde, Zeewolde at the scouting landgoed there. With the network infrastructure at these hacker festivals, we're running a small-scale temporary ISP. It has its own AS number, IP space, etc. We're deploying an on-site fiber optic backbone with a local data center facility, and we're also providing co-location for some other teams that are involved with the network at the festival. On the one hand, the network is providing just public internet connectivity for visitors, both wired and wireless, but it's also providing private VLANs for different teams, such as teams that are doing video streaming, VoIP, IPDECT, ArtNet, ticket scanning, GSM, power monitoring, etc., etc. When thinking about hacker camps, the thing that usually first comes to my mind are the what we call datenkloos, or data toilets, and they are a relatively cheap enclosure to temporarily house equipment on a field, and it's well, correct me if I'm wrong, but I think it was first deployed by the Germans, hence the German name, Datenklo, at CC camp in 2003, but it was kind of before my time. And 20 years later, at the CC camp in 2023, over 65 of them were deployed, scattered across the field. If you want to connect, the Datenklo is offering both wired and wireless services. And if you want to connect with your cable to the Datenklo, then you roll out your cable to your tent, and you place one end of the cable outside of the door, next to the door of the Datenklo. And then there is a group of volunteers that is just running around on the field, passing by all the Datenklos and checking if there's cables to connect, and then they will connect you up to a switch, and the switch is sitting on the lid of the toilet in the Datenklo. And if you're lucky, you would be able to get a 10 gigabit connection if you support 10 G-base-T on your device. And for Wi-Fi, there is a access point mounted on a wooden pole, and this wooden pole is then installed in the quote-unquote chimney from the Dixie. The access point is just an indoor access point that is installed in a plastic box. I also have a demo here. It's like this. It's indoor made outdoor. Yeah, it's a very cheap way to make it. To get out, because if you have to buy the real outdoor access points, they are like 5 times more expensive or something. And then at the very top of the wooden pole, there is a device called what we call an ohm light, or an ArtNet LED sleeve, and this is a I think Niels can like do a demo of that, but that's yeah, it's that thing, yeah, yeah. So it's like yeah, it's a device that is driving these RGB LEDs, and it's receiving ArtNet data over the network, and then that is generating this animation. And this sort of doubles as a poor man's network monitoring, because yeah, if it is disconnected from the network, it will just become like a static white light. And if there's no power, then it's doing nothing. So it's sort of giving an indication to the attendees of the festival if the Datenklo, is it working or not. So that's yeah. Yeah, these Ohm lights are quite old by now because they were made for the Hacker Camp Ohm 2013, so they're 12 years old now. And there's actually a new version being made for the next Hacker Camp in 2025. Yeah, the Datenklos, they're uplinked with fiber optic uplinks, and we use these armored fiber cables. And we usually attach them to the 400-volt power cables that are laying on the terrain, so people are not tripping over them. Yeah, then for all the fiber uplinks of the Datenklo, what we want to achieve with this is that we give each Datenklo a light path or a channel back to the core of the network, because the on-site power or the on-field power is not always as reliable as we would like it to be. So if there's any sort of power outage, then we are sort of reducing the blast zone. So it's maybe a power outage of one Datenklo will only affect that Datenklo and nothing else. At the earlier Hacker Camps, we started off doing this by using BiDi transceivers on multi-core fibers that we were sort of daisy chaining from Datenklo to Datenklo. And then in the last two camps, we have been using a new version of this, which is using CWDM OADMs, just to tie into Yuri's story a little bit. And where we are using a 40G LR4 transceiver on the core side of the network that is broken out into 4 times 10 gig on different channels. And I actually have this device here. It's this is the OADM. We will have one of these OADMs per Datenklo, and it's in a configuration where we have 4 Datenklos that are in a ring. And the OADM is an east-west configuration, and on each leg we are adding and dropping 1 channel. And in each Datenklo it's a different channel, so we have 12, 70, 12, 19, etc. And with this design we were able to also add redundancy, because each Datenklo will have a 10 gig uplink, and 1 over east and 1 over east, 1 over west. And this design is double the density over BiDi, and there is no muxes required on the core side. It's just the 40G LR4 transceivers with the LC connector. We've made or purchased together with a manufacturer, Tallgrass, 56 of these muxes. Then we also have been using Netbox quite extensively at these Hacker Camps. We're using it mostly for configuration, generation, and automation with a tool called IMF CFG, which was developed inside the hacker community. It's available on GitHub. We'd like to pre-pan all of the patches we want to do on-site in Netbox, because Netbox has a quite handy cable trace feature. So if you're planning something complex with patch panels and muxes and whatnot, then planning this stuff in Netbox is quite useful. We have a few Netbox scripts available that we are using to populate the data in Netbox for patch panels, muxes, and those kind of things, because it can be quite tedious if you have to do this, if you have to click all these cables manually in Netbox. So with the data that we have in Netbox, we are able to generate printed patching instructions that all of the volunteers that are running around connecting things up, they can take this paper and then use this as a reference to how they should connect everything up inside of these Datenklos. Lastly, there is also a Netbox script available that we give access to other teams, and this is a sort of self-service portal for them. If they want to have a port changed to their VLAN, they can do it just through this Netbox interface, and then the configuration is deployed automatically on the switch. And then I also have some pictures. This is Wi-Fi from on MCH 2022 and CC Camp in 2023. You can see here on the left, these are all these wooden poles that are going out to be deployed on the data enclosure. Last CC Camp, we had a twin data center design. Well, on the left side, it looks okay, because it's like that was in the porter cabin, and we had airco, and it was all fancy. But we sort of last minute decided, like, hey, it would be nice if we can have a second location for, like, we have 2 core switches, 2 core routers, and 2 MX204 external routers, and we want to split them over 2 sites. And there was, on this site, there was an abandoned house available. And as it happened to be, the most convenient spot to put the equipment in was in a bathroom. So that, These are more data center pictures. On the left side is MCH 2022. This was actually on as a fixed building on site at the Scouting Landgoed. So that's quite convenient to have those buildings already there. We just had to pop in some aircos, and then we were good to go. And at EMF 2024, there was chosen to put everything inside a cooling container. So this actually is a container that is used to cool drinks, and it also doubles quite nicely as a data center cooling thing. So, great. That was it.
Now for the third and final presentation, we quickly switch to Andrew Yurchenko, who works for Cisco. He has a couple of event networks to tell us about, actually. And then we go to the panel with all 3 here at this table, ready to ask all your questions or to discuss amongst them. I don't know. We'll see. Andrew.
So event networks is not my day job. In the day job, I'm lucky to work on open source. I work on VPP, but event networks are my very passionate hobby. And as Nick said, I work on 2 networks that are fairly different. One, you probably know both of them, because one probably doesn't need introduction, Cisco Live, so that's probably about 10,000 attendees, about 16,000 overall devices. Pretty intense network in a sense that not just wireless, but also there is a lot of people connecting to ports all the time. There is a lot of people making exhibitions, so they bring their devices, they need to connect their devices. And the scale of that network is about 1,000 access points. We have about 500-ish switches. And as you see, well, so there is also the fairly dense, high-density wireless installation. So for the keynote, and that's what you see on the slide, the number of people in a single room is about 6,000. So that's pretty, well, sitting like you sitting, except imagine 6,000 people. So that's pretty fun. And the deployment of that network, so the actual installation time is about 2-3 days. So it's pretty high-intensity event. The other network is quite a bit different because it is a charity event which is held in Alps. It's called Alps 6, so it's a Dutch fundraiser for cancer research. And it is quite different in the sense that whereas with Cisco Live, which travels different venues, and there the design constraints are kind of more dictated by the venues, and the venues are designed for the events, right? Here, we do some of the things that Ariane mentioned. So the network, so you see the track there, from start to the top where the NOC is, the distance of this track is 14 kilometers, and yeah, the elevation difference is 1 kilometer. So we have interesting things like radio links, and that's quite exciting. And that's the view from the radio link. So you see the antenna, and the other antenna is on that small spot there. So you can barely see that. So that's a little bit different deployment scenario. And here it is people coming for making the bike race, and people are more using ATMs, phones, video screens, and so on that are attached to the network. So it is much less dynamic environment in a sense of people plugging things in and out, except maybe sometimes plugging the phones into the USB ports on the switches, which is kind of unfortunate. But otherwise, it's pretty relaxed. So, and kind of I wanted to distill a little bit some of the post hoc principles that we arrived to in terms of designing, and what do we use as principles in evolving these networks. So first, composability. At some point, we figured out that, actually, we plan things very well, but if you ever did the event network, then at least at Cisco Live, for example, there is always the floor plans that come already for this year. There are already floor plans, but the floor plans keep coming. And they'll keep coming up to a point where we're already on site, we're about to deploy, and then arrives, oh, sorry, this is the latest final version 10 done. And that's probably not the last one. So realistically, you know that there will be always changes. And kind of we noticed at some point, well, it would be nice if we could rearrange things. And kind of that's the big question that we try to ask ourselves, is at the access layer at least, because the diagram at the top is kind of the two data center design, 2 core design, so that's fairly standard, right? But the access layer is not even there, because the access layer, it's kind of kettle, right? It can change. And we achieved that by using DHCP for all the switch addresses. So none of the switches actually have static addresses in the network. So this gives a very nice flexibility, is that you can take any switch, you can plug in any uplink port into any downlink port, the switch gets IP address for IPv4, for IPv6 it's linked locals, that's very easy. OSPF comes up, all the switches are in area 0, and boom, you have the routing. So address plan allows for 200 layer 3 switches, so they're all in the same area 0. And currently in AlpDuZes, we use, well, all the switches are layer 3, so it's kind of microsegmentation if you wish. And in Cisco Live, we have about 50, 55, depending on the event. I wanted to show as well the diagram. So the diagram on the bottom is the diagram of AlpDuZes. And as you see, it's pretty dynamic, so it's kind of organic. You cannot have the luxury of designing the network. You're more connecting the things where they can be connected. And it was pretty scary first time I went there, because at that time it was running flat layer 2 with VLANs, mind you, but it was still flat layer 2. And when I counted, it was almost beyond the maximum radius for the spanning tree by a couple of hops. So that was when I said, okay, we'll move all of this to layer 3, and now it is fully layer 3 routed network. Now, as I was telling about composability, and the second part, which also worth taking in mind, is dynamicity, which is that not only things move in the topology, but the things also move in terms of people plugging in things where they may or may not plug things in. So first of all, what helped a lot was the fairly robust layer 2 port config. So the layer 2 access switches, they have pretty much all of the security features turned on. So that's one of the port configs. So you see it's pretty much anything we could turn on is turned on. We do not allow switches to be connected to the layer 2 access switches for obvious reasons, because then the potential for the loops is much higher, and troubleshooting loops in the flat network, it's not great. So we lock down the config pretty well. Another thing that we kind of piloted the last year is, for Cisco Live at least, the deployment map. So we have the software that updates the maps that we pre-plan, where we put the switches, where we put the access points, and then with the automation tooling that we have, it dynamically updates where the switch was deployed, where the switch was taken away. If we replace the switch, that's also updated. So again, we kind of try to both pre-plan as much as possible because we really have fairly little time on site, but at the same time to be as dynamic as possible. And in terms of, again, changes, we kind of split the configuration changes into two parts. One part, which is the majority of them, is the service changes on the port. So I connect an access point. It needs to go in a special VLAN for the access points. It needs to have multicast. So both networks have fully functioning multicast because we run TV, we run multicast for IPv6 for the wireless. So these types of changes are very, very frequent. And for Cisco Live, we do typically about a couple thousand of them. So obviously that, well, in the event like this, if you do it so fast, you kind of shouldn't have too much process around that. So we just allow everybody on the NOC, so anybody of those 60 people that you saw, they can go to the tooling, they can click on the switch, they can select the ports that they need to change the service on, and that gets done. 5–10 seconds is done. On the other hand, things like updating the access lists, they're a little bit trickier, right? As someone who have been dealing with the PICs and ASA firewalls for a long time, well, they can be tricky. Let's put it this way. And those who used to configure PICs and ASA firewalls, they will know. So for that, we have a little bit more heavy process, but it's more that then there is a person reviewing the changes. Nonetheless, we still don't put too much paperwork on the changes, but we put a heavy emphasis on logging and alerting. So every change in the network, every configuration change gets logged. And even the inventory movement, because as I said, we have more than 500 switches and 1,000 access points. So they all go out, they all need to come back in. And the tear down happens in the span of a few hours. So for that, we had to come up with a system where, and you see me on that slide, so each switch has a barcode printed on it, and the barcode has the MAC address. And that barcode is scannable, so it's a little bit like when you go shopping. When people take the switches to deploy, they scan them, and when they come back, they scan them again, so we know whether the switch is out of the storage or whether it is in the storage. And yeah, how do you know whether the switch is in or out? With that, we also have barcode for people as well. So when you take out the switch, you scan your own badge, and then you scan the switches. So we know who took which switch. And vice versa, when you're bringing the switches, we kind of don't care who brought the switch back. So we care that it's in. So then you don't need to scan anything. You just scan the switches, and then that sets their status as checked in. And again, yeah, there is quite a lot of new technologies in terms of inventory mapping, but this is in place since probably 7 years already, and it works fairly well. So now this brings me to the topic of automation. And none of what we do would be possible without automation, so especially Cisco Live. And Cisco Live has, the NOC team is composed of a lot of people who are passionate about this stuff because it's not a day job for any of us. So there's a lot of automation. This event is an opportunity to automate something more. So there is always more than one way to automate things. And we use a lot of open source, obviously, but we use, as I said, we use the bespoke automation system that is, well, I mostly written or rewritten because I inherited it. Was written in C#, and I decided to learn Rust, so I rewrote it in Rust. And now it's 20,000 lines of Rust code. So it works pretty well and saves a lot of time. So with that system, we can track the inventory, we can track the reachability, we can do the configuration deployment, we can do the service port changes. At the same time, we use it as a glue to interface with the vendor products, because after all, well, I'm working for Cisco, so we kind of need to show some of the products that we produce and sell in the angle that is useful, right? So for example, the wireless devices are primarily deployed because that's Cisco Wireless that we use. It's deployed using the Catalyst Center with deployment maps and everything. And the bespoke tooling interacts with the Catalyst Center, doing the bidirectional synchronization of maps and the status. So that allows both wireless team know about where the switches are, and it allows the team doing the deployment of the switches to know where the access points are. So that creates a much better cohesion, which, as you saw, there is about 60 people in the Nlnog team. So that's very helpful. And yes, I think that's pretty much it, what I had.
Thank you, Andrew. If you would go to the table as well, and just stay around the table, please. All right, so there you have it. 3 ways of doing event networks. The idea is that now we let the guys discuss amongst each other, or they answer your questions, or both. One thing I took away is the difference in how to approach this, with Andre looking really like they bring their network, and the network includes a router, it includes Rpki, it includes lots of net, and it includes lots of IPv6, of course. And the other guys, they also bring the network, but it's more like a wireless network. And I don't know if it's connected, but Andre spoke half of his presentation about geolocation, and you guys didn't say a word about it. So I wonder if there's anybody who wants to, if you come a little bit closer to the table, it's better for the video. But if you guys want to say a word about geolocation, why, would it be important for you or not?
No, so this is working, yeah. Yeah, at the hacker festivals, we tend to use both temp assignment space and just our primary space. And their geolocation is also an issue, so we also are using the same RFC GeoFeed.
I don't remember the numbers.
8805 or something.
8805, yeah.
Yeah, okay. Yeah. No, yeah, we use the same thing. Yeah, we have somebody in the Nlnog who's very passionate about geolocation as well.
Can anybody check where we are now?
Yeah, maybe, well, with event infra, yeah, maybe we don't have this RFC 8805.
I hear Amersfoort. Yeah? We are in Amersfoort. So, okay, good to know.
Yeah, we don't use the RFC because it's not ripe space and we don't have control over the object. And blah, blah,
good.
so, yeah.
All right, I see there is a question from the audience. Julia.
Mostly for the hacker camp, but it might be for all of you. How do you deal with your IPA space getting dirty? Because people like Cloudflare and Akamai don't need much of an excuse to block a whole class C or more.
Yeah, we do try to deal with abuse email as much as possible, but there is, of course, a problem is that we don't always know where the users are. And we also are not logging a whole lot of things in the network because for privacy reasons. So, but yeah, we do, if possible, we would like to handle those abuse requests. And in the past years, there's not that much abuse that we abuse email that we have actually received. So it seems that people are not that adventurous anymore at these hacker festivals.
Boring.
But yeah, we do want to be sort of good internet citizens and handle the abuse requests if they're coming in.
Thank you, Phil.
I think there is another question there, Marijn.
It's a really short anecdote about problems with geolocation, and I think it was event infra access points. Where the scout event in Norway, where on the last day before the event started, they brought in the cheapest payment terminals they could find, which were region locked to Norway. We connected them to the network, and they were like, "No, you're in the Netherlands, so we won't work." I think it was based on the MAC addresses of the access points. In the end, they had to bring other payment terminals because we weren't able to fix it within one day. But that was an interesting problem we came across. In 2 or 3 years, we will do the same thing in Poland for 45,000 people, and let's hope that we can fix it by then.
All right.
For some reason, we have a payment terminal at RIPE meeting that used to have Wi-Fi, and the new generation has 4G. I guess it relates to this fact as well.
Yeah.
Yeah, the geolocation based on the BSSIDs of the access points is quite stupid. Yeah.
Okay, next question from the audience. I haven't looked at that site yet, so there you go.
Antoine van Schuren, yeah. Basically, it's an extension to the first question. When I look at the configuration of the networks, I don't see, or you haven't told us any bit about security tooling or security measures on the network. You know, to do security on a network, you have to know your customer base, right? And of course, with these events, you don't know your customers because they pop in and you know them at the last minute. So can you tell me a little bit about, you know, the security tooling that you do, or extra security measures on port configurations or stuff like that?
I guess I can take that because I wasn't talking before. So we have a full-on security operations center. So we have 4 people doing security and only security out of those 60. And then using all the spectrum of products that exist. So yeah, all the extended detection and response and all of that.
So do you have, for example, DDoS mitigation systems and that sort of?
Yes, so we actually have people walking and finding the people who are misbehaving sometimes. It's a lot of fun, both on the IP level and on the radio level, because as well, if you have 6,000 people, you need to have very careful planning, even in 5 gigahertz, because we don't do 2.4 at all in that density. And it's funny because I even entertained myself once as well with walking around with the Mac and trying to locate the person who was broadcasting the SSID. It's a lot of fun.
Next question, Tijn.
Hi. When you get to a random location and you want to announce your ASN, if I ring up KPN and I want to say I want to announce my ASN from at home, they say go away. How do you fix that problem?
Well, this is a different type of contract in our case. So basically, we just have this contract template saying, hey, we want a connectivity sponsor and we want you to propagate our ASN with our prefixes that are listed here. So it's not a KPN home-based connection. It's 10 gig Ethernet link that is set up for us. But how Event Infra does it, I'm actually curious. How this event, for instance, is connected? What's the upstream here?
Oh yeah, so actually we are tunneling all the traffic. But it's so the connection here is from SurfNet, and we're just tunneling everything over SurfNet back to NICAV. So it's a very small hop, and that's a way to get connectivity as well. And we can do it like with IPsec or WireGuard or whatever you want. Yeah.
GRE, yeah. Thank you.
Okay, over to my right again.
Right, this is primarily a question for Arjan, but maybe Andre and Andrew might have an interesting insight on this. Because Event Infra quite often ships crates of equipment to other events and all that, how do you keep track of that, or where do you store that? How do you log that?
Inventory system?
Yeah. That might be, was a bit curious about if you have any specific insights on that.
Yeah. Now, we do have some homebrew inventory system which we like to open source at some point, or maybe rewrite and then open source. But that's also like using like barcode scanning, that kind of stuff, and then checking stuff into a location. When you're loaning it out and when you're getting it back in.
Pretty much the same for us, with the slight caveat that we also, out of this 1,000 access points, about half or more than the half is borrowed. And borrowing them involves renaming all of them. And it also involves renaming back. So we try to keep really careful track of them. So yes, as a result, I now have all of the access points in RAI.
We have the luxury of having equipment basically just for RIPE meetings. So it's either on RIPE meeting or in the flight cases in the storage, and then it just moves here and there. So we don't have to really track the assets.
Yeah. There is also a remote question, I think.
Actually, no.
Oh,
he just doesn't want.
Poor Teun, sorry.
No, he's a bit tied up there. So it continues on the previous question. Actually, it's how many times does equipment get lost, taken out, not scanned, or brought back and not scanned, and or returned equipment scanned that was not scanned when taken? So how do you deal with that? So.
Return equipment that was not scanned, that generally. Well, so it was happening before, so then you track it manually, obviously. Mm-hmm. But the interesting thing that I found out is that once we added the dynamic status of the equipment on the map, so the people who work in the field, so who actually bring the gear back and forth and who have to troubleshoot, then suddenly they understand why do they have to scan the equipment in and out. And that feedback loop was really cool because last year, we didn't have a single case where somebody didn't scan out or scan in because they are, well, then on the map, it doesn't show as it should show, and yeah, then I better scan it. So it's really about kind of making a feedback loop to people that they understand why they're doing the process. And that seemed to work really amazingly well.
So that also means you don't lose that much equipment?
No. Okay. Sometimes it walks away, but that's very, luckily very small. And sometimes what happens is that we put it too early. Well, early on we put it too early, and then sometimes there is still construction going on, and yeah, so the compact switch once went under a cherry picker and didn't survive that, unfortunately.
We have an issue of forgotten switch in one of the patch room in one hotel sometime. So sometimes this happens, but it was just our fault that we just forget.
DHL is not always very good at shipping things.
Fair enough.
Well, it did not get lost, but it got pretty damaged on the way. So.
Now they should work on some geolocation protocol. We have time for 2 more short questions. Arjen?
Well, it's more of an anecdote from the security measures. To get the law servants happy for, what the heck, we actually had to put in a snort box facing outward, so to protect the internet against the hackers. We had to use snort to look at the traffic going outwards, and that made the servants of the law happy. I think the snort box was implemented like 3 days into the event because we did not have time for it. Then it didn't take the loads. We did some things with uneven MAC addresses to divide the load on 2 cords, and at the end of the event it sort of worked and nobody looked at it, but it kept everybody happy in the end. And I have a bunch of anecdotes about lost equipment and stuff, but I'll keep it with this.
Thank you, Arjen. Last one, Sander.
Yeah, when the payment terminal thing with the geolocation was mentioned, I actually realized I once had the opposite problem. It was an ITF meeting in Maastricht, I think, where they took the payment terminals from the US to the Netherlands. So I went to my hotel, I checked in, I went to the venue, I paid for the meeting fee, and 5 minutes later my credit card was blocked because I did 2 transactions on 2 different continents within 5 minutes.
That's great. Thank you, everybody. Thank you, Andre, Arjan, and Andrew, for your presentations. There is one more presentation to go before lunch, and it is a little bit more serious note. I think there are many people here who will run something like a family email server or something similar. And yeah, the thing is, what happens to that server, what happens to that email, what happens maybe to files that you share in case of some unfortunate incident where you don't have access to that server anymore. And Teun has courageously volunteered to present about this to us and put his thoughts in a row, and who knows, there will be comments afterwards to help us all deal with this issue. Teun.
Yes, thanks. Hi again. Let's see if that starts to work. Yes, okay, so this is about your digital legacy. Yeah, it's a talk based on observations I made after several people passed away in our community over the last couple of years. It happens to us. Many of us are getting older, and well, even younger people happen to pass away at some time. So I noticed some things, and I thought it would be useful to tell you about it. And that's, well, like Niels already said, a huge part of our lives is online. We do a lot of things digitally nowadays, and not just us. No, anyone does. But we are a bit different from most people. We do things a little different. Instead of using the common, typically used things, we tend to build our own stuff. We build our own mail servers, our own file sharing stuff. We host our own websites, register our domains, stuff like that. And yeah, that's cool, because that's a thing where we learn. We investigate, we try to try out new things, and maybe even bring it back to our company and say, hey, well, this is cool, we should make a product out of this. So it allows us to grow, it makes us better. And we share this with our friends and family because it's so easy. And well, yeah, you have your email server and you tell your wife, oh, here, I will register your domain and I will fix an email for you. And then you have a friend that has a problem with his DNS and you say, oh, no problem, I'll host your DNS. And well, it goes on and on and on. And I think a lot of us know this. And still, that's a good thing. It's we helping out to each other. And we also have a life that's a bit unknown to many people who are not familiar with our community. It's either we're active on IRC, on our Discord, we're part of an open source community project, or well, gaming, you name it. It's a whole world that many other people don't even know about, because it's, well, not a physical world, it's the digital world. But what happens then when we're not around anymore? And then you start looking at practical stuff, like, do your relatives know who to contact? Who needs to be notified of your passing? Do they know who to invite to a ceremony? Stuff like that. And we like to do crazy stuff. We like to work with passwords, Storm Crypto, MFA, VPNs, you name it. We test it out and we build it, and it works perfectly fine because it's for us. And that's another problem. It's for us, so we don't have to document it. And even if we document it, it's outdated, it's incomplete, and well, it's just absent. So relatives have no idea where to start. Well, you leave them with some system that is a black box that hosts something about email or a website or passwords, but they have no idea where to start, and they lack the knowledge and the skills to deal with that. So there may be some things we need to think about before that time comes. We need to document some of these important things and tell our relatives about this. So you need to write down what servers you have, or what DNS domains you register, or things like that. And passwords is a very important one as well. And you need to tell your relatives who to reach out to, because often they just lack the skills. They don't know how to deal with this. And one way to help them is to tell them, well, if something would happen to me, go to, well, my colleague, my friend, this is the person, and they can help you. They know who to notify, they know how to deal with problems if your mail doesn't work anymore, or transfer it, or whatever needs to be done. But they can help out. And then there's all the deals we have. Write down what the services you buy, where you buy them, why you buy them, what deals you made. Do I offer backup DNS services for someone? Is someone hosting, running a VM on my server? Stuff like that. If nothing is written down, no one will ever know why it's there once you're not there anymore. But there's another side. There may be some things you don't ever want others to see, even when you're not there anymore. Some things are so personal, you don't want to ever share them with others. And so it's not like you have to give them the keys to your fort and give them everything you have. So you need to think about it. What is important to share? What do they need to know? What should they never see? Because some of the things you may have, like love letters, digital, to your a former lover, may not be the nicest thing to have your wife discover, to name something. So you don't also want people to go poking through your stuff before it's time. So you need to have some way to deal with these things. How do you do a timely transition of, well, mostly the rights to your data when it's needed? Some services offer good ways for that. Some have an option to either hand over the master password of a password vault once you haven't logged in for a number of days and after several reminders. Well, some things don't, and you have to think about how to deal with that. And these things aren't always needed only when you're, well, where your absence isn't permanent. What if you end up in the hospital and are unable to work with your computer for a longer time? It may be needed that someone helps you to get your server up and running again. So documenting these things is really needed to get, well, for your continuity. I chose not to speak about solutions here because every situation is different. Everyone has its own tools they use, their own products, their own way of implementing things. So this is not a talk about how to do this. It's all mostly about how to think about what you need to do. And you should just think about it and pick whatever suits your needs, what fits your situation. And as with all documentation, if you write down things, make sure to keep it up to date, because writing down things for once is, well, it's a job we mostly don't like to do, but we do. And then it ends up on a piece of paper somewhere in a corner in a book. And we forget to think about it, and years later it may be totally useless because everything changed. So write it down and keep it up to date. And please don't wait too long, because you never know what happens. Irony has it that one of my former colleagues passed away, and we heard about this today. So, and he was only 52. So this happens, and it may happen sooner than you would like. This is my talk, and thank you very much.
I don't think there will be questions, but I'm sure there will be comments.
Well, I feel seen. This also applies not just to your personal life, but also your work life. At work, there is a tamper-evident envelope in the fire safe, and it is labelled only to be opened in the event of Julia's death. That has all the master passwords that are needed to decrypt my personal laptop. This also applies to not just someone dying, but we have a lot of stuff with 2FA. friend of mine had their phone nicked recently. They then went to buy a new phone, only for the transactions to be declined because the 2FA was their phone.
Yep.
So they now have a tamper-evident bag in my fire safe with all of their 2FA codes, the emergency ones. This is a reminder for everyone. I'm going to use that word again, tamper-evident bag, so that you have the problem of not being used before its time, or at least proof that it's not been used before its time. And get a friend that you trust.
Exactly.
You can get a fire safe for under 100 euros, stick it somewhere where it's not obvious, and have your friend's codes in yours, have your codes in your friends as well as in yours, so that you've got basically what's needed in the event that something happens. Thank you.
Very good points. Thank you. Yeah.
Go ahead.
Hey, I think much a continuation of Julia's point there, but I was going to make the point of, well, really a ponderance of when you give access to somebody to this vault, or however you do it, I think it's important to also, while you can, regularly renew that access. Because I was thinking about, okay, what happens if you put all this together, you give this all to somebody, say an envelope in a fire safe, and then you suddenly, for whatever reason, don't want that person to be able to take charge of that thing?
Yeah.
How do you handle this later? I guess the logical point is treat it as a breach and roll and reset. But I'm also thinking, is there a better way to deal with this?
It's a very good point. I don't know if there's a better way. I would assume, assume it's a breach. Sounds like the logical way, but it can be a lot of work depending on how many passwords you're sharing and stuff like that. But yeah.
Thank
Oh.
Hi. Did you want to add on that, or?
Yeah.
Oh, sorry.
Sorry. So one good solution for that is not to use one friend, but multiple friends. There's something called Shazam Shared Secrets, where you can give multiple keys away. You need at least a couple to work together to unlock something like that.
It's a very good suggestion. Thanks.
I've got a little bit of a tip. I've got a password manager with a nice password vault. And I've set it up that someone can log into it if I pass away. And I chose my brothers to have access to that and not my parents, because hopefully they pass away before me. Hopefully that will take a few years yet. But take that into account that you pick someone who is roughly the same age. So you don't have to update that prematurely. So both my brothers can log in and look at all my passwords, and then they have access to email. And if you have email and 2FA and passwords, then they can access everything. So
sounds good. Yeah, basically this is business continuity planning for families, what we're talking about.
Yeah, about that, one online comment is that this is also important for non-tech savvy people.
Absolutely.
Talk about this with your family, with your friends.
Absolutely.
The other
but
way around. Yeah.
If your mail is in Google, your domains are in Google, stuff like that, Google knows how to deal with this, and Facebook knows how to deal with it. It makes it more difficult because we do things in our own way and not in a standardized way, and we choose our own things.
I have another comment to add. Don't mix your private stuff with your work stuff. You'll lose access to your work's accounts. So, and I know a lot of people are very used to using their work accounts for doing personal stuff as well. So keep them separate.
Very good.
Thank you all, and thank you, Teun, for sharing your thoughts here. Now, with that, we get to another break. But before I mention the L word and you all storm out, I have a couple of notes. There are 2 tables with food, and both tables have been designed to be passed on both sides. So each table can host 2 queues. So there are 4 queues in total. We have done our QoS here. Also, if you have lunch, you can have it inside, of course, but you can also go outside, or you can go to one of the studios in the back of the room if you want to be in a little quieter area. I think that's it. I think I can now mention the word. It's lunchtime until 13:45. But in case you got here by plane, you may want to be sure that there are people looking after your flight. People who make sure that your plane does not crash into others and gets to the gate safely. And what is better just to see eye to eye with the man who, well, okay, one of the people who makes this happen. It's my pleasure to introduce Rudy van Drunen from Air Traffic Control Netherlands, who do a surprising amount of networking, and he is here to tell us all about it.
Thank you. It's an honor to be here, and well, doing the after lunch slot is always a difficult one. So a quick agenda. I'll introduce myself. I'll take some time to talk about air traffic control and how we operate, what we do, and what networking is all about at our site. What networks we have a lot, and what applications we run, and how we actually manage that running 24/7. So that's because we are a safety organization, a important thing. So I will talk about evolution versus revolution. At our side, it's more evolution instead of changing everything at once, revolution. And I'll tell you a little about what we're up to in the next steps in our systems. So myself, I'm a network engineer. I'm 1.5 years at LVNL. Before that, I come from a hardware background, did systems, software, and now moving in the networking. I really love the lower parts of the stack. And in my spare time, I'm chairman of the board of the Nlnog. I do some ham radio photography and try to keep track of everything that's going on around that. So, after Air Traffic Control in the Netherlands, I got more than 1,000 colleagues. And that's not just the people that are in the control tower at Schiphol Airport, but it's also people that work at the other regional airports. And there's a lot of people that work in our radar center at Schiphol East, so not in the tower. Of those 1,000 people, there's 250 actually air traffic controllers. So there are either people that sit at the tower and guide planes on the field, or work at behind the radar screen in our radar center. So what do? We make sure that 71 million passengers at Schiphol Airport get to their destination safely. And that's a total of about 500,000 flights at Schiphol and another 614,000 flights in, well, 488,000 flights in 22. You see there the corona thing going on. That is transit. So we also control the flights that fly over Dutch airspace, for example, to land at London Heathrow or something, some other fields. So where are we? We're at Schiphol at 3 locations. So the 2 control towers at Schiphol, and we have the radar center at Schiphol East, and we also have people at all orange locations, which are the civil airfields in the Netherlands. We have people in the tower there, and people maintaining the infrastructure over there. And right now we are in a program to also incorporate the military fields into one air traffic control environment. So how does this look inside? So on the left side you see the screens at Schiphol Oost, the headquarters where the radar operators are, and of course we have the tower. This is the Schiphol Center Tower, where you have the view of the complete field. What you see is there that it's all electronic, so there's no paper involved. In the early days, they had these little wooden pieces with strips of paper where they wrote the call sign of the airplane, and then they had that stacked physically. Now, in the tower, they use an iPad or a big touchscreen for that. So we control the local traffic from the tower on the field. We have approach control that's arrivals and departure. For example, if a plane wants to land at Schiphol, then and comes from the south and the just south of the border approach takes it over from radar control and guides the plane to actually in front of the runway. And we have area control, which is planes that are in the upper airspace, and for example, landing at in England or so, that they fly over our airspace. And then there's above that, all traffic is handled by the European Eurocontrol from Brussels, the control center for the layers above that. But actually, to do that, we need some networking, because we have all those screens. And what do we do? What's the main thing? We need to be sure that planes do not crash into each other. That's the bottom line, right? That's our job, and we need to do that by trying to separate planes. Like in the horizontal plane, we need to have them 5 nautical miles, that's 10 kilometers apart. That's for the upper part of area control, and when they come into the field just in front of the runway, then the limits are 3 miles. But also, they need to be separated vertically. So that's 300 meters, 1,000 foot. Like in air traffic control, everything is non-metric. So that's the thing. So how do we do that? We can't see the planes. Like if they're up in the airspace, there's only a radar that we have when they like take off and land and are on the runway. We can see them from the tower, but everything beyond that, it's radar. And the other thing is, so we need a radar image, and we need to have a way of talking to the plane, talking to the crew, and that's the most important thing, to actually tell them by voice what the air traffic controller wants the plane to do. The air traffic controller is like the boss. The plane does not see other planes. So the pilot has to rely on the air traffic controller that he or she tells him, like to fly a certain route, or fly a certain height, or fly a certain speed, not touching the other plane. Because if you have two planes like flying 500 miles an hour and they are 5 nautical miles apart, it just takes 18 seconds to like collide. So it's a tricky thing. You got some time, but it's not that it's all an easy thing. And the important thing is the planes can't see each other. The radar controller sees them all on the screen and has that picture. So to get that picture, to get that radar picture, we need to have the data from remote sites, from radars, into the control center. So there's a whole lot of networking behind that. And to be sure that it always works, like 24/7, we need 24/7 systems running, and we can't like have either no radar image or no voice comms, because that's also going through the network. We have a three-lane principle in the in the complete systems. We have primary systems, the systems that normally work, the traffic controller uses. We have then backup systems, and they are constantly online, so there's just a single switch from one system to the other system. And then if those fail, like if we suffer a really big big outage, then we also we have last resort systems, and they're actually also in a physically different location. So they're not in the same building. So if that plane lands not on the runway, but a couple of miles either east or west, and there's no radar room anymore, we have last resort systems on a different location. And to zoom in a little more, our critical systems are connected to two networks. So we have two networks carrying the same data, and they're connected they're both connected to a system, and the application running on that system serves the redundancy. So what we have is the air traffic control system gets radar data from two sources, and it's up to the control system to actually use one source or the other source and detect whether one source is not available. So those networks, well, great, but what does run on those networks? Well, of course, we have systems for air traffic control itself, and we have systems for the pilots, like systems on the ground that the pilots use for either navigation to get in front of the runway, like the instrument landing system. And of course, well, the systems we use to actually see where the plane is and what the plane is doing. That's mostly radar. We have multiple radar sources coming through the networks to our data center, be combined, put data with that radar picture and put it on the screen of the air traffic controller. Next to that, we saw that we also need some means of communication to the plane. There's voice to the airplane and back, but also voice ground to ground, because that one controller that handles that plane flying over the Netherlands and wanting to land in like London Heathrow needs to hand it off to the controller in England, the center in England. So he can calling up and say, hey, this plane is I got it still on a certain height, and you expect it on a lower height, so that's coming. And a lot goes by network communication, but also a voice communications comes in very handy sometimes. So there's a voice communication system that in one press of a button you get the controller in like England or Brussels, or a Eurocontrol for the upper layers. Next to that, we have the other information that the controller needs is like the flight plan. Where does this plane come from? What waypoints is it gonna take to actually fly into Schiphol? All that is coming from Eurocontrol Brussels over networking. We need to know what the current meteorological situation is on the field. Like the Dutch Meteorological Association has sensors on the airfields, like for wind, for temperature, wind direction, wind speed. Everything is fed into a system and presented to the air traffic controller, so he can tell to the pilot, hey, there's a crosswind, or also swapping runways. We have multiple runways at Schiphol, and when the wind direction changes, runways have to be swapped. So planes have to guide to a different route. Of course, we have monitoring control of all our systems, not only the server systems, but also the complete network. And from all beacons and auxiliary systems that help the pilots navigate and help the pilots line up to the runway. We have networks to that. And how does that look then? Getting in a little more technical. Like, we have all big colored balls are networks within our environment. So if a asset that can be like a radio transmitter or a radio receiver or a direction finder wants to talk to the on the right side the system that produces that image on the screen, then it goes through a number of different networks. We have local networks at the Schiphol or region fields that are connected with the network called Mustang through to the local network at the main site at Schiphol Oost, and also we have external network connections to like adjacent senders or like the flight plan database at Eurocontrol and whatnot. And of course we have the auxiliary networks that supports the rest of the non-ops people, the office automation and that kind of stuff. So we have networks on and around the airfields, rings. At Schiphol, we have a number of rings along the runways that connect the sensors to the network. We have a nationwide transport network that gets the data into Schiphol. We have the internal network at Schiphol, and we have a fairly big firewall environment that's in front of that. How does that look in some other nice picture? Like we have networks all over the place on all fields that are connected to the main site. So there's a lot of networking going on. A lot, a very complex environment. Well, there is some history. And because we are in the aviation field, there's slow development on systems. For example, an instrument landing environment with the antennas in front of the runway has a lifetime of 30 years. So each and every 30 years, you swap that. Instead of like every 4 years, you put in new switches and that kind of stuff. So, and with that, it is super reliable. So we want to have 100% uptime because we are in a safety critical organization. Yeah, because of that, we are not in an IP only environment. Like still systems that we run and have to communicate over the network use serial RS-232 interfaces, E1 interfaces, and that we need to slowly move while the plane is flying in midair because we cannot have downtime. So we have there issues of redundant stuff. We have complete. We have environments that are not yet redundant, and how do you migrate that in midair? So we have challenges in technology. Older technology, like 30 years ago, needs to work with a newer technology that you buy now or that you bought 5 years ago. And we have two completely separated environments. We have a production environment that's operational, and we have a development, test, acceptance, and education environment that's not in the operational thing. And the way that you can run changes is completely different from the non-ops and the ops. Because the ops, you're touching the live systems with the live data, and if you pull a plug and you pull the wrong plug, there's no radio screen. And we saw that that might be tricky then. How do we do that? We in a transition of all sorts of networks, like more than 400 different networks that are built and maintained by the different product groups. Like the radar group had their own network, their own service, their own network people. The surveillance group had their own network people, and that was like interconnected. And we like to move to a network as a service thing, where we have one network platform or multiple network platforms that are interconnected, and that the radar can be connected to that, and like I showed you before. So we need to standardize, and that's standardize on platforms. And we do that, try to do that in an agile way, moving from the temporary workarounds. Hey, I got this set up this way, and hey, I got this set up this way, and now it needs to talk to each other into that air traffic control environment. So that's what we do. And yeah, standardization while integrating 400 plus legacy networks, and also supporting new stuff, because there's also new developments in, well, I want to use this, I want to use that technology, stuff goes on. Change in changing environments. There's a lot of regulations in our business, and they change. So then you have to cope with that and adapt your systems according that. And of course, there's changes in enhancing safety. When something happens, when we have an issue occur, then we need to learn from that, change our stuff, change the procedures, but also maybe change the hardware, change the environment to be continuously safe. And 24/7. So it's backed by regulations, procedures, and keeping it constantly running. It's no use, there's no option of saying, hey, like the next 2 weeks, we need to do some big upgrades, and like, yeah, this first week, close the airspace, and then we slowly ramp up. That's a no-no. So that's a challenge. How do we do that? Well, by challenging work, interesting things, talking to a lot of stakeholders, designing resilient environments, designing redundant environments, talking to the people that are working behind the screen or in the tower. What do they need? What can they? What room is there for time stuff to upgrade, stuff to change, and of course, new developments, because in 2026 we will be having a completely new air traffic control system. So the heart of it, the stuff that drives the radar screen. So we are together with the German air traffic control, a Spanish contractor is building a completely new environment for us. And currently we are in different phases of testing because it has to be tested, verified, checked against regulations, tested. Every tiny change has to go through that whole thing. We completely built a new building for that, like 10 years ago when this project started. And this project is, well, this is not to be proud of. It's on the top 5 list of projects in the Netherlands that the government is running with a lot of money. So that we are doing. So that's part of that is new networks, changes in networks. What we also are looking into is having the towers at the remote fields replaced by cameras, brought those camera images over the network to Schiphol, have the tower controllers there. And what also is very important is, because we do our own education, because there is no school for air traffic controllers, we have simulators to do the educational part. That's part of the simulators that we have at Schiphol. They need to be supported too, and they need to be fed with data. And last but not least, we want to, well, there's a program to integrate also the military air traffic control into our into our organization and also into our infrastructure. So a lot of stuff going on. I think I'm completely running over time, but maybe there's a quick question. One? There's 35 seconds, I see.
I'm wondering, Rudy, if there is a question from the room, go ahead, but I'm wondering, an organization like yours where the network has to be up 24/7, it's in a sense comparable to an ISP network that many of us have here, which also needs to be up and running 24/7. But I have a feeling that in your organization, the word change is regarded even more dangerously than in ours. Is there something you can say about that?
Yeah, well, it's all a matter of risk, and the risk aversiveness in our organization is maybe a little bigger than in the ISP. So yeah, everybody has that in their mind, but also one needs to work within that framework.
We have time for a few short questions because we are stealing the time from Bert, so that's not something you want to do. Boudewijn, go ahead.
Sorry.
Okay. We are all a fan of multiple redundant systems. Many of us are less a fan of actually testing out a failover to the redundancy. Have you done that to that one or the last resort system ever?
Yes. Of course, we need to, and we need to prove that. But we have for each and every system, we have a test environment where we can test stuff out and then move it to production. But before moving to production, failover tests have to be done and have to be shown that things work. And actually, sometimes the practice demands that we do a failover test in operation.
Right.
It just works.
Dick, go ahead.
Thank you. I have a bit of a technical question, if that's okay. I was wondering if the information from the radar systems, I can imagine that is ADSB. Is that done by software-defined radio, then transported via an IP stack to the people that actually need to read the radar, or is that more of an analog system or some other kind of system?
Well, the radars themselves are just analog sender and the receivers, and they're at different locations, and they're just the moving moving radars. Then the signal is digitally processed. And then this digital signal is transported over the network to the system where a radar image of a large environment is being comprised, because there's multiple radar sources. And next to radar, we also use multilateration, like different receivers that receive the broadcasts of the airplanes and then calculate in time difference where that airplane is. And that's mainly for ground operations. We use that at Schiphol Airport a lot.
Okay, cool. Thank you very much.
All right, go ahead.
You mentioned about sending two streams of data simultaneously to the application for redundancy. So how does this application cope with it? Doesn't it has a high PPS? Do you have DPDK, or does it have hardware accelerated? And do you put your voice traffic also there? But does it introduce any latency? Does it work well?
Yeah, it's dependent on the application. Like the application gets two data streams, and one application just chooses that data stream. The other application chooses the other data stream. But those data streams need to be same.
So it has to pick one. It doesn't get the same and picks the right one or the correct one. It doesn't do correct.
Last question, Andrew.
Yeah. So you were talking about moving from multiple hacks to platforms, from multiple different disparate systems. But in that move, you would also inevitably lose some of the diversity, which also to an extent brings up some resiliency. So how do you tackle that?
For example, the complete, we have the different air traffic control systems. The main backup and last resort are different systems, different code base, different environments. So it's completely like separated. So a last slide. Well, you can help us, and there's a website. Kom werken bij LVNL. So if you want to like, we need some good architectures. We need some good network engineers. So come talk to me, or it's fun.
Wonderful. Thank you, Rudy. All right, from an organization that may be a little bit averse to change, we go to a person who is always his same self, and we love him for that. But he's also going to talk about change for us today. It's my pleasure to introduce, once again on stage, Bert Hubert.
Yeah, there we are. So thank you very much for all showing up again, and it's always a pleasure to be here, and always very happy that you want me to speak. I really enjoyed it. And this time I want to talk about lifelong learning, and that really is I think the fourth part of the Nlnog work trilogy. Most good trilogies have 4 parts. In part 1 we said, well, how come my boss is such an idiot, but he makes more money than I do and has a better life? How do I get some of that? And part 2 was, how do I get a better job or a better paying job? And 3, should I even have a job? You will get the PDF of these slides on the Nlnog site, and there are notes underneath with URLs to many things, including to these previous 3 presentations. And here today I'm talking about lifelong learning. So we first had to talk about how do I optimize my career, or should I even have a job? And this is about the daily choices that we all face. We need to do something. Am I going to do it by hand? Am I going to automate it? Am I going to script it? And am I going to use technologies that I've used for the past 25 years already? Or am I going to pick something new for a change? Or am I the kind of person that always picks something new and never becomes any good at technology because I do not spend enough time with it? And you can see there's a bit of tension there in how much do I invest in learning new things, and how much do I enjoy working with the things that I know already. And these are choices you make every day for every little task, for every little project. But if you add this up for over like 30 years, this sort of defines your whole professional development. Because if you keep choosing the same old stuff for 25 years, eventually it does not turn out well. Unless you are very lucky, and we get to that. But if you keep picking new things and you never become any good at any particular technology, you might end up as a manager. But we talk about that as well. It might actually work for you. It might actually work for you. That's also part of the presentation. So I'm a sort of terrible person to ask about career management, because I've been a researcher, I've been a sort of journalist, I've been a scientist, I've been a spy apparently. I've been a spy regulator. So I'm not a good person to ask for how do I focus on my career. It's like asking a drug dealer, do you know about drugs? Say, I do, but well, I don't, of course. These days, on one sort of professional announcement, I'm on the advisory board of the Dutch Authority for Terrorism and Child Sexual Exploitation Related Material, the ATKM. If you ever feel, as an internet service provider, that the ATKM is full of shit, you can talk to me, because I can then advise them not to. This is not a joke, this is actually officially my function there. So my career is all over the place. So I sort of know what I'm talking about. So I did DNA research and got that published in Nature.com. And I have a satellite monitoring network which looks super scary. And and I write about climate change, and I'm sort of a government influencer these days. And so it's all over the place. But still, I do know a little bit what I'm talking about, because for the past 35 years, I've been programming in C++. I write websites in C++, and very good ones too. And I write terrible JavaScript and Python. I've been writing terrible JavaScript and Python for the past 15 years. It's still terrible. But from that, you can see that in one part of my sort of career, I keep doing new things. And there is another area where I said, no, this is my thing and don't touch it. I'm good at this. I'm going to continue using this until it's outlawed by the Rust strike force. So I do know. So now let's get to the meat of the story. I even wrote a whole article in the IEEE journal how terrible modern software is. So see, but now I'm going to tell you about change, the future. There are two areas I want to talk about: lifelong learning, technology, and sort of trying different things. I'm going to start with technology. And we get new technologies all the time. So if you've been around for a bit, you have been through various hype cycles already. A particular favorite of mine is UML, which is now almost forgotten, which was an idea that managers could write sort of diagrams how the software would work, and then programmers would type that in. Of course, it didn't work, but it was a great sell because the managers decide what we buy, so you should always pitch it to them. And of course, then everything had to be in the second life. We had to be agile, blockchain, Bitcoin, 5G self-driving cars. They actually tried to sell us to that a few years ago. I still don't know what 5G has to do with self-driving cars, but many people apparently thought that these were very related. The digital transformation, I think it's done by now, the digital transformation. I never hear about it anymore, so they probably finished it. DevOps, Kubernetes, quantum computing, and of course the big one, AI. But it's good to realize that AI is only the last in the series of technological changes that have been sent to us. It's the biggest one, though. And of course, you may wonder, you sit there, you say, like, look, I'm just trying to do my job. I'm just trying to get the planes to land safely. Do I really have to have AI in my controller? But the problem is, it sounds funny, but it's a real problem. I think really probably one day, one point, someone's going to come down from the headquarters. For some reason, the technologists are always in the cellar somewhere, and the management is on top. And they will come down and say, why don't we have AI in here? And you go like, because we want the damn planes to land, and not have some sort of approximation of where the 6th runway could be. But you all recognize, from the laughter I hear, that you all recognize that you've had that occasion where someone goes down and says, how about we DevOps HR? You're like, please don't. So in a way, a technical career is this array of new technical things coming down and us having to sort of judge on that. Is this good? Is this new thing good? Is this new thing bad? Should we do it? Should we try to hide it from our management so they no longer ask about it? And now the current example, and maybe the biggest one ever, is AI. Everyone has an opinion about AI. And everyone is, of course, secretly either worried that they're not doing enough AI or that they will be replaced by AI. And it's good when thinking about evaluating new technologies to spend some time on your own feelings about this. And we'll get to that in a later slide. But I think almost everyone here will have a personal opinion on if AI is bullshit, or if it's great, or if you will be replaced by AI, or if everyone else will be replaced by AI, except you. But it's good to realize that you already have an... Is there anyone with no opinion on AI? That's ChatGPT enters the chat. We're good, we're good. So this is a diagram, and here you can see that I'm not good at making diagrams. The big blob represents the skills that an employer needs. Those are the things that they need their personnel to be able to do. And the little pentagon in the middle, that's like the new employee. Just at the beginning of their career, they're not yet very good at what they do, but what they do is smack in the middle of what the employer needs. And over time, you get more experience. You learn more things and you become better at the core of what you do. And eventually you become very good at a number of things and you explore the area of things that you can also do, like my JavaScript skills. And eventually you're like nuclear grade good at some core technology. Like I'm like the best Perl programmer ever, or my IPv4 skills are like out there. But this is quite painful because it's quite easy to go to work and know, look, I'm really good at Python, and I'm going to do some more Python, and I'm going to become even better at Python. It's a very natural thing to do. You don't have to think about this. You just go sit there and like, I'm going to use my favorite tool to do my favorite job, and I'm going to get even better at it. And one day you come to the office and you find out that you are now extremely good at things that your employer doesn't really want anymore. And this is very painful, also psychologically, because you personally feel like I'm like really good at this stuff. I'm like the BGP king, I'm the DHCP master. And your employer says we outsourced all of the DHCP. We are no longer sure what DHCP is. And you sit there, yeah, but I'm the best at it. And this is, of course, these few slides represents like 20 years of career development. But this point can suddenly happen. It might not be that bad. There might be other employers that are by then extremely hot for your DHCP skills, so it might end well. It might also turn out differently, where you suddenly have to find a new job and you end somewhere in the basement. And I want to be sure that I am in this picture. So I am also in this picture. This is not necessarily a terrible outcome. This could definitely be that you say, look, I'm now doing the technology I love, but I used to do it as an exciting place, and now I work at the tax office. And you can find that doing Python at the tax office is just a very valuable job, and it's maybe just not as exciting as joining that internet service provider 25 years ago, or that gaming platform that you used to work for. But this is a case where you had a career development, but you did not develop your career sort of developed you. And suddenly you have a new job, and you could also not have this. This is a pretty good outcome. But once you sit here, you might suddenly be very good at a technology that everyone has decided they no longer care about. So with this, I'd like to hammer home the importance of steering your knowledge development, because you make these choices every day. Will I use Python? Will I use Go? Will I try Kubernetes for a while? Shall I go cloud native? And the interesting thing is that many of these choices are personal choices that you make behind your desk. So if you start a big new project, of course, everyone wants to figure out what technology you're going to use. But if you sit there and your task is to solve a specific problem, you have a lot of options of doing that, and it's your choice. It might be wise to think about that choice. Now, we cannot take all new things seriously. You would go batshit insane if you tried all the new JavaScript frameworks. Or if you tried all the new orchestration platforms or every new cloud service, you would go completely crazy if you did that. But the other way around, if you just sit there and go like, hey, I'm rocking it with Awk, eventually you could run into problems. So you have to strike a balance. And there's this very wise philosopher, Schopenhauer. He's originally in German, but even for German this is hard to read. But in English he said, well, if you want to do the good things in life, you have to read the good books and not read the bad books. And you have to really make sure that you waste no time on the wrong things, because the wrong things will distract you from the right things. So you have to make a choice. And I also made that choice once. And back in 2011, I said, I made a good study of Bitcoin and blockchain and stuff, and I decided I'm not going to do anything with it. And I'm not even going to do anything with people that do something with that. And that was a very wise choice. That saved me so much time, and time which I could focus on other things, and it was very good. And sadly, in that same year, without thinking, I decided that all this deep learning stuff was bullshit. And that was wrong. That was the wrong choice. And because I thought it was all this Californian self-driving Elon Musk shit, cannot be good. That was bad. And then the people from Google, they invented the language model called BERT. And I should have taken the hint. I should have said, well, okay, if you start naming things after me, maybe I should take another look. But I did not. And it turns out they even have a field called Bertology. And anyhow, I ignored all that stuff. And that was sad, because in 2020, actually, the ChatGPT arrived in 2020, which is 2 years before anyone else realized that it arrived. In 2020, it was a Python API. So not a nice website, but with the Python API, you could already have the ChatGPT experience. Now, I'm not saying that it's all good. It's definitely not all good. But it is a revolution. And it is a revolution that is something that we need to know about, that we need to study. But because I decided to just ignore all this AI stuff, I didn't do it. So then to compensate, I wrote a whole thing, deep learning from scratch, which might be interesting for you also, if you want to sort of figure out what's going on. There's a link in the PDF. And this starts with an empty directory and ends up with a thing that can read my handwriting, which is beyond most people. And that's all in like 2,000 lines of code. It's sort of fun. So I made up for my little mistake there. But the key thing here is, it is good to decide that this technology is not for me, but do think about it a bit first. So this is Douglas Adams, who also wrote a 5-part trilogy even. And he was not only an interesting writer, but also sort of a philosopher. And he came to the point that, look, anything that's invented when you're born is like normal. And there's an area in your life between 15 and 35 that all kind of stuff is new, and you can make a career in it, and you should really do it. And anything invented after that is just wrong. It is good to realize this, even though this is not as true as it was. There is this, I think we all recognize a little bit of, yeah, this is normal, and this is, to these young people. And this is sort of the old world. The old world, the more senior you were in a company, the more conservative you were. So this is one of the founders of computing itself, Ken Olsen. Many of these quotes, if you chase them down, are not true. These ones are actually true. He actually said this: there's no reason why anyone would want a computer in their home. Thank you, Ken. I have 3 computers in my pocket, as far as I know. This is another one. This is serious people in the year 2000 said, well, the internet might just go away. We have a Nobel Prize winner here, Paul Krugman, in 1998, which is even a bit later, said the internet is going to peak in 2005, and by then we're going to move on. This is sort of the old world, in which the more senior you were, the more conservative you were. That meant that if you had wanted to advance as a technical person, you would have to get room for it, you would have to ask permission for change and stuff. And this has now changed, because we now have all kinds of managers that are like, why are we not yet into DevOps AI? I read about that. And we should be cloud AI, quantum blockchain native. That's a real problem. That is a real problem, that you sit there, you want to get your job done, and your upper management and the shareholders, by the way. The shareholders are just behind your management and saying, look, we need to be with these Tensor AI chips. And this was back when Dilbert was fun, and Dilbert was not an idiot. And this is actually very old. So this is not new. This is the manager that comes in, we need a SQL database. And Dilbert is wondering, should I ignore this guy? And he said, well, what color should it be? And it should be mauve, because it has the most RAM. Which clearly makes very clear that management had no idea what they were doing, and you can just safely ignore them. But this is now not a rare coincidence. This happens all the time. And the problem now is that people are even writing LinkedIn think pieces on this, that CEOs should stop chasing the shiny new thing. And they even made a graph of this. This is the official Gartner hype graph, in which they make a graph of all hype technologies. And it's interesting that they sort of jumped the shark that way, because they even say, look, this is a hype. We've made it official. So this is not a list of interesting new technologies. It is a list of the most modern hype. And we're going to update that every year. It's sort of fun. This is the 2021 version, which had non-fungible tokens, NFTs, on it. Okay. And but it also had like weird thing like machine-readable legislation and influence engineering. And then a few years later, they have a whole new hype cycle. And so it now lists WebAssembly, which is already sort of descending again because people wisely woke up to the idea that running software in your browser on a virtualized platform is maybe one layer too many. But these things are very important. And from this hype cycle, we as sort of technical engineering people might eventually come to the conclusion that all this new stuff is shit. Which is a mental shortcut. Where you go like, look, I've seen what you came in with your NFTs and your blockchains and your DevOps thingies. And from now on, I'm going to ignore all the new things. Because I have decided that 2012 maybe was the high point of technology. And for everyone will be a personal year in which you sort of conclude, well, everything that they invent from now on is just pants. And then you end up in this career trap where you've decided that, look, my whatever JavaScript skills, they are the best. And I no longer care about new things. And that's a very dangerous point in your career. And I think we can all recognize that point where you go like, oh, what now? And that's sad because many of us have still like 30 years of career left. It might be worth thinking a bit about it. So what do new technologies look like? The black thick line, the top line, that represents your skills at a certain technology. And over time, you have become frighteningly good at your favorite technology. And then, at sort of midpoint of your career, someone shows up with something new. And the new shiny thing, that's the orange lower line with the arrow. And it's new, and it's out of the box. It can do many things that you spent 20 years learning. But the question is, will this new thing eventually be better than your skills or not? And frankly, we don't know. So if you're like really good with Python and Go comes along and Go does some things out of the box really well, is it time to give up on Python? We don't know. And because it could end up like this. It could be that this new thing is actually just a lot better than what you were doing. Arguably, this happened to Perl and Python, where eventually Python was just so much better. And in this case, you would be wise to say, well, let's take a look at Python, or whatever, as a new thing. But it might also end up like this, and this is actually far more common. Some new technology comes along, out of the box, it is quite capable. Well, it is not as capable as the thing you are good at. So for example, if you were a C++ programmer, there are things you can do in C++ that are extremely hard to do in Go. But there are many things that are like really easy to do in Go. And eventually, you might be the best person in your chosen programming language or field, but new people are like 75% as productive as you are after only a few years of exercise. And eventually, this sort of mediocre technology takes over because it's far easier to find new employees that know this new technology than know your old technology. So as engineers, we might be, the best technology should win and should always win. But very often will you get that, well, this technology is not quite as good, but lots of people understand it. So effectively, it won. Something to think about. And then there's also this one. These are the people that I like to do new things. And so I jump from language to language. I run from routing technology to routing technology. And I never get really good at anything. And this is a fun way, actually, to spend your career because you keep learning new things. It's really fun. You can invite it to all the fun conferences and it's really fun, but you never really get anywhere. Nevertheless, it could be a lot of fun. And you might end up actually, it was a little bit of a joke at the beginning, but after like 20 years of this, you might end up as an interesting manager. Because you have seen many different things. You've never become really good at one specific technology, but you now know many different technologies a little bit. And if you can avoid turning into this huge mansplainer, that now says, look, I was programming in Perl, anyhow. You know these people, and some of us are these people, and it actually does pay to stick around with a certain technology until you really master it. So these are sort of the scenarios with new technologies. And this is the kind of stuff that is coming towards us. So we have cloud native. Everything should, of course, right now we're in a phase where everyone says everything should always move to the cloud. Whereas the very large players are again discovering, well, actually that's rather expensive, so maybe we shouldn't do that. Kubernetes is one of these things that some people, they tie their shoelaces with Kubernetes, I think. And they should do everything with it. There are some people that can no longer think if AI is not in the project. So from this slide, you can see that we have a lot to evaluate. There's a lot of technology that we need to form an opinion about. And it's also good to see some of the things that we never hear about anymore, like big data, which is sort of this mythical thing that would kind of change everything without us really knowing what it was, except the operational definition that more than 65,000 rows, which didn't fit in Excel. But it pays attention to sort of follow the hype cycle and to form a reasoned opinion of new technologies. And especially it's important not to do that alone, because that's too much work. So here I want to sort of go over a few of the changes that we've seen over time. So you can let your mind go over, well, what do I think about that? So in the olden days, we did everything in awk and in shell. And then Perl came around, and then these new guys from PHP, which we all hated, but actually they made some very interesting products. Python came around, and then Go was the new hotness, and now people are sort of doing everything in JavaScript, and I don't know why, with 15,000 dependencies or 1,500. And there are now people that want to write scripts in Rust or Swift. And you can see that this spans sort of 20 years, and over time, with each of these things, we will have had our favorites, or I'm not ever going to... Java isn't even on there, which is an example sort of my blind spot, because earlier in my career, when I didn't really think it through, I was like, I'm not touching Java ever. Maybe it was a good choice, I don't know. But I ignored it so much that I didn't put it on this slide. Whereas there are like millions of people that live every day in Java, and actually it still sort of runs the world, I think. This is also an interesting evolution. Yeah, I mean, it used to be that people had whole naming schemes for their servers, and now you're some kind of idiot if you name your server, except if you name it server 1, maybe. But and then you see that people had various automation, orchestration platforms, and Kubernetes, and now it has to be... And this is not going to stop changing. And each time we'll have to form an opinions like, is Kubernetes the thing forever? Or should we just stop doing computers and only do services? These are choices that we have to continuously have to make, and if you make them wrong, you suddenly have no job. So it's not a small thing. I love this one, and I lived through this. So I wrote a piece of software that was utterly dependent on MySQL, and every once in a while MySQL would become extremely slow and no longer do what I wanted. And people blamed that on the database. Actually, they blamed that on the language of the database. They said this SQL thing is all wrong. The future is NoSQL. And everyone jumped on that bandwagon. People started doing financial services on MongoDB. I had a lucky experience. I was sniffing out MongoDB back when it was really small, and they had an IRC channel, and the founder was on there, and whatever. And I found out that sometimes Mongo would just throw away half of my data. And so I asked them, I said, yeah, you should not stop the daemon ever. You should just... I said, what? I said, no, you just have to make sure that it completes the writing. I said, it told me it completed the writing. Yeah, we don't actually check for that. And just don't ever shut it down. Okay, I was like, okay, I'm leaving this IRC channel now, and I'm washing my client. And but what I find so very interesting about this one, this is one of the very few cases where a decade later, we are now rediscovering how incredibly good these SQL databases are. And that it was actually not their fault that they didn't do what we wanted. We just wanted some very strange things from them. And now you see that PostgreSQL and SQLite are better than ever. They're like extremely good. And even young people are now finding out that SQL is actually a very interesting way of telling a database what you want it to do. because it's not only key value stores. And so this is a case where the circle went round, where the people that ignored the whole NoSQL development actually came out great, because they're now super duper SQL experts, and it's all hot again. And so this happens from time to time. It's not always, the new stuff doesn't always take over. Perl is also still around. Yeah. The reason I put this on here, because almost everyone has a sort of opinion on systemd, like it's terrible, and Leonard is an idiot, and people went so far as to sort of fork all of Debian, which is like big work, to create a system without systemd. People fled to FreeBSD, and so it is a big thing. But we never really got around to, there was more feelings than facts. People say, yeah, I hate systemd because I once had this terrible experience somewhere. Life would have been better if the community had decided, say, okay, systemd, actually there are serious quality issues in there, but let's go fix them. And that's not what happened. We actually started, let's complain about them. And many people are like extremely passionate in their opinion about systemd, and very often in an unjustified way. Because they come back to, yeah, like back in 2012, I had, I know, terrible back then. But it would have been better to focus just on the quality instead of focusing on our opinions. But we did. Yeah, this is, of course, the big one. This is the one that we're living through right now. Technically speaking, many of the tasks that we do could feasibly be enhanced using AI. I'm not saying that it would be good, but it is definitely in the realm, should I look at this? So you have a log, all kinds of entries in the log, and you're wondering, are there any strange entries in there? AI can do that for you. If you have 5,000 trouble tickets open, and you have these, and you wonder, is there a theme in these 5,000 tickets? Is there anything big that is causing like 2,000 of these 5,000 issues? AI could tell you. But there are lots of reasons why you might not want to do that. For example, if you do it naively, it means that you would have to send all your 5,000 trouble tickets to California, where they would do then further AI on it. But if you did a little bit more work, you could run the AI locally and benefit from it today. These are real choices where I think there are many sort of diehards that will say, I should do the thinking here, and not the computer. And there are other people that are saying, I cannot wait to replace all my colleagues by AI. But your personal position in here is going to be very important. Because you could either figure out the good bits, and let me give you an example of the good bits. If you run your own mail interface, you will have challenges with spam filtering. And sometimes it works well, sometimes it doesn't. Spam filtering is actually extremely easy for AI to do. So if you run a large language model on your own server, and you can just ask it, is this message spam? And it's probably right. You don't even have to learn it anything. It will just probably do that out of the box. That means that as people that do things with computers, today, we could solve problems with AI on our computers without the cloud, without Elon Musk. It could actually do something useful. Whereas I already know that many of you are like, no, not ever going to do that. It hallucinates things. It is bad. And you might also be right at that. But if we mess this up, then a whole new generation comes along that does everything with AI, and they don't do it right. So it is on us to figure out, can we use this technology? Can the AI predict that my server will fall over at 3 a.m.? Maybe it can. I would love for my server to already announce to me that it's going to fall over at 3 a.m. Because otherwise it will announce that at 3 a.m. So here you can test yourself. You sit behind your computer, there's a problem that needs solving, and you're going to either copy-paste something by hand 5,000 times, or maybe this is the time when you say, I'm going to download this huge binary, they're big, and see what the AI makes of it. Because it's trivial right now to download stuff and interface with it from Python and just ask the AI, do you think this message is spam or not? And your own computer will calculate that. And you can calibrate yourself on this. If you're already convinced that this will never be good, then you can prepare for this building here. You can go live here. Wow, that's a lot of slides. Yeah. Then you can prepare for this building and say, okay, I've just shut off any new things in my life. I'm going to work somewhere where they only do old things. And again, depending on where you are in your career, that might be a good choice. It might be that you're like, hey, I just do work and I go home, I get paid, it's fine. But make it a conscious choice. Don't just say, I'm not going to do AI because it's AI and Tesla. Those are not good reasons. A few other things. Technologies. I see people get extremely passionate about why certain technologies are good or bad. So people are like, yeah, ZFS, this is the best thing since sliced bread. It can do no wrong. It ate my data 3 times, but it can do no wrong. And there are people that have this relationship with C++, for example. Now, it's actually not true. I sort of, if you have a healthy relationship with technology, you love it and hate it. Because you love it because you know it can do these good things for me, and I also have a very good list of all the things that are terrible. That's a healthy relation with technology. If you find yourself just loving technology because it's technology, then you're actually in love. You're not being an engineer at that point. Technologies are not football teams or musicians. Now, of course, no one here is a fan of football or musicians, I think, but in normal circumstances this works. But you can be a huge fan of actual open source software. So you could be a huge fan of SQLite, for example. I am, because I've worked with their community, and their community is great. They solve your problems, they listen to you. It is okay to love SQLite. They also think it's okay. But it's more difficult if you love Kubernetes. Because Kubernetes is not your community, they are not your friends. There are very big commercial companies behind it. And you should look at yourself and say, why do I love this technology? What is good about this stuff? So we come here to the algorithm. If you encounter a new technology, first have no opinion. Just say, okay, this new database arrived, this vector database arrived on the scene. I'm going to study it, but I'm not immediately going to form a judgment, which is difficult because our brains are effectively judgment machines. They sit there all day long saying, this is good, 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 bad, bad, good. No, give it a rest. No, something new comes along, read about it, but try to stay neutral on it. And very important is again the role of hype. So you go to Hacker News or whatever, and everyone there says, yeah, this is the best thing since sliced bread, or it's the worst thing since Linux. However, do not get your opinions from those people. But do consider your own feelings. So for example, if you love a new piece of technology because it's like the other things that you love. Okay, well, so let's say you really love cloud stuff, something new cloud comes along, and you might say, hey, I like it already. I haven't really looked at it, but I like it already. Or if you're like me, I, for example, struggle. Let's say Google comes up with something new in the cloud. I really have to say, okay, I'm going to take a look if it's good, because I'm already feeling that it's terrible. But if you really take a look at it, you can find out, okay, this is actually good. This is worthwhile, even though it came from this place that I do not like. This is still the good stuff. For example, Facebook, Meta, makes some awesome technology. But if I think too much about Facebook, I would not see that, because I would only see Facebook. The other neat trick that I cannot recommend enough, if someone says, you should be using X, you should be doing this, you should be doing that, go do it. Because that is a neat trick, because many people that are super enthusiastic about the technology, they are so enthusiastic because they've never tried it. So as Bjarne Stroustrup, the inventor of C++, said, there are 2 kinds of programming languages, the ones that people complain about and the ones that no one uses. And so one neat trick, if someone says you must use this new thing, okay, go do it. And you might very quickly discover that it actually sucks. And then you can go back to your friend and say, hey, I'm trying your new thing. Can you help me now? And you'll find that either they fix your problem, which is good, because then you have some good technology, or you find out that they were just in love with this new technology because they hadn't actually tried it. Free trick. The fifth thing is interesting. I told you that there is so much new technology that comes towards us that it's a full-time job evaluating all of that. You cannot do that. However, you can go to Nlnog or to your own personnel, your own colleagues, and say, I'm going to present on this new database that I tried out. And I liked it because it did the following things really well, and I didn't like it because it did the following things not that well. And in that way, you can all learn from each other. And so you sort of crowdsource your judgment. And that's good for you, and that's good for your listeners. So I would recommend anyone that if you have any kind of personnel event or go to Nlnog, they say, hey, I tried this new vector database, and this is what I make of it. And then you get audience research. So together you can form an opinion on new things. So we're quickly running out of time. So I want to mention one completely different thing. We now spoke about technology, which means becoming an ever better engineer. But there are other things in engineering, it turns out. If you ever get the opportunity within your organization or company or hobby or volunteer work, whatever, to do something completely different, I really recommend that. I put that in bold: customer support. You will never understand customers unless you've spent time helping them. And even if you have spent time helping them, it doesn't mean that you will, from that point, understand all of it, because it's... so the people that have done customer support know what I'm talking about. But it's really, I can guarantee you, if you have not done any customer support in a help desk or ticket, you will not understand what is happening outside the world. So do not only focus on engineering. If you have any chance to broaden your scope, please do it. Because the interesting thing is, let's say you're like a super duper programmer, a SQL guy, and this is how good you are at many things. And now you do an interesting look at the programming bar. It just says, okay, you're 25 programmer, whatever. Now you've done some other work, and suddenly you've turned into C++. Okay, but you are now also a better programmer. How does that work? Previously, when you programmed stuff, you did maybe not have a good model of that people divorce or die or move or whatever. And that means that in your programming, you will also not have taken measures so that you can support a family divorcing. Because you've never thought about that. And so it turns out that if you broaden your scope, you become better at everything. Because you have a better picture of what could go wrong, or what would happen if normal people use your product. It is really worthwhile to not just only focus on technology, but also learn something really weird, like participate in the rebuilding project of your organization. Or if HR has a role of, I don't know, developer, ambassador, do that for a while. You will learn so much, and it will even turn you into a better engineer. Well, this is sort of the HR view of the world. You can only achieve true greatness if you focus on one thing. And I have to say that people that are in personnel departments, they really love this stuff, because they want to have their employee type such and such, and they can do the following 3 things, which works really well for them. But it turns out that if you learn many different things, you get a whole new view on life. And that prevents you from ending up in this comic. Yeah, this happens a lot. Where you just become a super duper engineer, and then one says, you're so good with computers, we're going to make you a manager now. And we're not going to help you with that, actually. We're just going to assume that you can transform all these computing skills into management skills. And both of the chairs in this comic are a terrible place to be. Because you don't ever want to hear this, and you don't ever want to tell someone that. Look, we have no career path for you. But if you broadened yourself sufficiently in the course of your career, you would not end up here, because you might be better prepared for a different role in the company elsewhere. So if you ever get the opportunity to do something non-technical, then I would recommend doing it. Briefly, some of you are managers. You can raise your hand if you are. Yeah, very brave, very brave. No, but management actually is like super important and not easy. And I'm not here to make fun of management. But you have a very important role. If you go like, look, all our projects need to be on time. So we're going to do all our projects the way we've always done them. We're going to use this database, we're going to use that platform, we're going to use that website. Then you should not be amazed that no innovation happens in your company. That people will only learn and try new things if you give them time for that. And if you visibly appreciate it. And if you have not wasted their time with the quantum blockchain. Because if you have people chasing these new things, they're like, okay, you just want shiny new things. You don't actually want me to improve. So it's very important if you are in any kind of management to visibly support people doing new things. And also, if the new thing fails, turn it into a learning experience. Have people do a presentation on it. We tried MongoDB and it ate all our financials. But share that news. And then the manager should like visibly come up to the stage, and you cannot be ridiculous enough about this. You can just go on stage and say, I'm so happy that this failed. And then continue applauding until everyone believes that you actually are happy that it failed. And of course you aren't happy that it failed, but it should be very clear that we want you to continue to innovate and try new things. And not make jokes about, yeah, haha, that's the last time we did that. Because then no one is going to learn anything. The last two bullet points are about valuing and rewarding. If you have an employee that did something new, then, and if you have a bonus or a whatever salary scale, award them for it. Because nothing speaks louder than actually paying people for improving. This is often forgotten in the Netherlands, so I put it in bold. So, we're nearly done. Lifelong learning, that doesn't mean that you have to go on training courses all day long. Don't just like or hate new things. If something new comes along, give yourself the time to study it. Study it together with colleagues, present about it, because if you disregard this, eventually your company will have moved away from you and you will have decided that no new technology after 2015 was any good. And that's a bad place to be in. If you ever get the opportunity to do something really new, by all means do it, even if it means spending like a few months with the help desk, especially if it means spending a few months with the help desk. The other thing is, if you work in an environment, then you don't have to feel bad about not wanting to do new things, because you are not stimulated to do new things, and you will realize that your management will only get mad at you if you try new things. And that means that you will have to try the new things at home, or at your hobby, at Nlnog maybe, and eventually find a new job. But then, I cannot stress this enough, the choices you make about the technologies you use over the decades are career defining. And therefore, it is quite sad that we just sit there and think like, ooh, systemd, bad. No, it should be like, I've thought long and hard about it, and systemd, bad. Nah, maybe not, but at least think about it. And with that, good luck, and thank you for your attention.
Thank you, Bert. We have time for 2 short questions. Julia.
You mentioned large language models, and that we should perhaps look at them. Given that they are essentially Grand Theft autocorrect at this stage...
No, you can just stop right now. You took the mental shortcut, which I warned about. You said, I'm not considering this because there are ethics, and I've decided they are bad. That need not be the case.
I have an actual question on that, though. How do we do this in an ethical way?
Well, you're not slaughtering children by running a Python program. Maybe good to realize that.
I'm doing it wrong.
Yeah, no, you're not. No, you're actually not. You're executing a Python program on your own computer, and you're not ripping off an artist or whatever. That's why I was quite careful in saying what I did. If you say, I'm going to do my AI through OpenAI as a cloud service, then you are complicit in their data model. They are learning from your company. You are making choices based on other people's data. But there are these fabulous models that you can just download on your own computer. They are self-contained. You could even train them on your own materials. So there are various ways in which this could be good. And I would urge, and I'm sorry that I was a bit harsh, but I would urge people not to make these mental shortcuts to disregard whole fields of technologies.
Thank you.
Okay, I will phrase it. Sorry. I will phrase this in AI terms because it's funny. Basically, you are describing an exploration-exploitation trade-off here in AI terms, or a multi-armed bandit problem. You need to try new things. You also need to do stuff that your employer actually wants you to do. How do you balance that? How do you focus enough on on your own development when your work week is like this?
Yeah, that's a good question. The one thing is, I fully appreciate that if you have a busy job, then that takes all the energy. So you cannot say, hey, I'm going to spend like another 5 hours on my computer at home. So you do not have infinite time to spend. One reason because of this, I stressed do this with colleagues. So not everyone can study everything, but if you are in a group of 20 people, you can probably get one person to look at something for a bit, and maybe later another person looks at it, and then share that information. Because we do not all need to make a personal evaluation of everything, we just need to make sure that enough brain cycles are spent on it, and that we can share the results. And Nlnog is, by the way, a wonderful place for presenting about new things that you tried, and then 250 people learn about that.
Does that answer your question?
It's a better answer than I had myself, so yeah.
Okay.
Okay. Thank you again, Bert. We are about 15 minutes late in the program. So what did we say for the tea break? Until 15:40 maybe? Yeah? So we go there, and then after the tea break, we have another 3 presentations plus the quiz. Be back at 15:40.
20 minuten gegeven, geloof ik.
Ja, dus we hebben een kwartier heb ik
Ik zet een kwartier. Would you please take your seats? Well, welcome back for the final part of this Nlnog day. We have 3 more presentations lined up for you before we go to the quiz. The next presentation is by a guy who has been on this very same stage multiple times, telling us about how to automate our networks. Today, he is here to tell us the opposite. Please welcome Robin Gilliamse.
Yeah, that was pretty much my introductory sentence. So, yeah, well, in my day job, so not just here on stage, but in my job, I talk to network operations teams, help them automate their work, be more efficient, be more effective. And today, I'm going to do something just a little different and talk about the opposite. So it's a bit of a long story, so let's start at my beginning. How did I get good at this? I got good at this by failing. I brought a prop, which you probably cannot read. This is a hefty study tome called Modern Control Engineering. Once upon a time, I studied aerospace engineering. And this is one of the topics where I failed at. It's very hard. It's called Modern, but the first edition was written in 1970. This particular book is over 2 decades old. I failed at this subject. And that's why I keep this book around, to remind me whenever I've got a feeling that I'm getting really, really smart, that I'm doing something really, really clever, remind me that I'm actually not clever enough to be a proper engineer. But that's one reason to keep it around. The other reason is that in between all the math in here, which to me is, after 20 years, pretty much indecipherable, there's a lot of interesting stuff about, control, systems, system engineering, inputs, outputs, that is also useful in our line of work as network engineers. And so that's what I'm going to do today, is I'm going to talk to you about some stuff that I learned from the field of aerospace engineering during my studies and a bit after, that we can apply to our job as network operators, network engineers. So back to my day job. This is one of the tools I use. It's a maturity ladder matrix It's a tool. Behind this is a whole bunch of questionnaires, checklists, to figure out where in an automation journey an operations team is. And it starts from the initial, the manual work, some initial scripting, automation, all the way up to the end goal of having a fully automated network that basically runs itself. And this matrix, this tool works very well at the lower levels, helping teams get better, get more effective. So when I started talking to teams about automation, most of my customers are at the lower end of the spectrum. I was pretty much at the lower end of the spectrum, and this works really well. Now, an interesting thing starts to happen once you get higher up on the ladder. When there's a certain inflection point where you start to think about how to remove the human from the loop, how to remove any human error, have computer systems run your computer systems, where the magic happens. And at that certain point, some interesting things started to happen. So the elephant in the room here is AI, and I'm not going to talk about AI much. Bert has pretty much got it covered. My personal opinion here, and certainly what you have to keep in mind for the rest of the presentation, AI is basically automation that might be a lot easier to write, harder to debug, but basically it's an automation tool. That's what it does. So, yeah. So I'm gonna discuss 3 topics from the field of aerospace engineering about automation, and this is the first one that I like to highlight because it's an interesting one. We all know there are a lot of problems with the airline industry. They're noisy, they're polluting, it's bad for the environment. So obviously there's a lot of engineering going on to make it better, to make an engine that's more quieter, more efficient, better for everybody. And also, incidentally, fuel costs are one of the big drivers for airline operational costs. So an efficient engine is a great way to save money. Unfortunately, this specific engine is the LEAP 1B engine that's used in the 737 MAX. And unfortunately, it's slightly bigger and heavier than the previous engines used in Boeing 737 aircraft. So they could use the engine, but they had to move it a bit forward and upward, which had a slight change on where the center of gravity is on an aircraft. And that's quite an important thing. Now, another cost-saving thing is that if you make an entirely different aircraft, you have to retrain all your pilots, which is very, very, very expensive and time-consuming. It's far better to make slight changes to an existing airframe, because you don't have to retrain your pilots, your mechanics, which is saving money for everybody. But how to fit that with those bigger moved engines, changed center of gravity? Well, you can use automation to help you with that. So because the center of gravity was moved, the aircraft has now become unstable. And the Boeing 737 is a very, very, very old, reliable, trusty airframe. It's a decade older than I am, and I'm not young. And it has also always been a very stable, very robust airframe. With the new engine, it has become unstable. So the engineers at Boeing invented a system called MCAS, an automation system, which basically helped the aircraft, whenever it entered an unstable phase, adjust the tail fin to put it back in a stable situation. That means the pilots don't have to even encounter any situation where the aircraft is unstable. Everybody's happy. So the first automation concept that I'd like to introduce is the automation surprise. And an automation surprise is something that happens when you have an automation running in your environment and it does something that the operator does not expect. The operator expects the system to behave in a certain way. The automation causes it to behave in a different way. An automation surprise. And that happened with the MCAS system. At a certain point, MCAS depends on some inputs, and when one of those inputs is wrong, it'll start pushing the aircraft in a more stable course, nose down. And when it's not necessary to do your nose down as an aircraft, you really don't want it to happen. The pilots did not expect that to happen, so they responded by pulling the nose up, start fighting the system. Because the problem was, they didn't retrain the pilots. So of course the MCAS was a nicely documented system. It was somewhere in the thousands of pages of documentation about the new 737 MAX, which obviously everybody has read. That operates in an aircraft. But when you're not being trained on it, you don't really know it. So the pilots were fighting the automation system, and in the end, the automation system wins. And that results in someone like John Oliver spending 20 minutes to explain very thoroughly what a shitty company you are. That's not a situation we want to be in. So, how to avoid such an automation surprise? Well, the obvious thing to do is make sure that there's someone paying attention to the system. Be sure that if you have an automation running in your system, that your operator always is keeping an eye on it. And I've got the picture here from Tesla. I don't know if any of you ride a Tesla, but Tesla has this autopilot function, and the autopilot function demands that you, as a driver, pilot, always keep your hands on the steering wheel. And there's absolutely no way to get around it, right? Yeah, okay. Which brings me to my next case. Let me introduce you to a very nice piece of automation called the auto throttle. And the auto throttle is an old piece of automation, very reliable, and it's very straightforward. What it does, you set a certain altitude and speed, and it'll physically move the aircraft throttles to maintain that speed and altitude. So that's very nice because it has good tactile feedback. You can see and you can feel where the throttles are. Very reliable. And as a human, you can always know what's going on and override it if necessary. Everybody happy? Okay, so concept number 2, automation-induced complacency. Whenever you have an automation running that is clean, reliable, trustworthy, you stop paying attention to it. If there's never an issue with the system, you stop paying attention. The squeaky wheel is the one that gets the oil. And this can happen with the auto throttle. And in fact, it did happen. Incidentally, that's another Boeing 737 story, where the auto throttle, the throttle levers, one of them was blocked. So the auto throttle, the nice clean piece of automation, was physically moving the throttle levers. But unfortunately, in the case of the Srivaya Air Flight 182, it was moving only one of the throttles. And the other one was blocked, resulting in the aircraft setting course to starboard. Which another piece of automation, the autopilot, was compensating by banking the aircraft back. But that increased the airspeed, so they need to move the throttles back further, which made the problem worse. And in the end, the aircraft was banking even more, and banking even more, and banking even more. Okay, at this point, the pilots start noticing that there's something wrong, and they need to take back control. So what they should have done is look at the throttles, because the throttles were set at a different setting. But they didn't, because that system always works. There's no problem in all the throttles. They grabbed the stick and started compensating. And that didn't work, which resulted again in a tragic accident with loss of life. So that's complacency. So how can we avoid such complacency happening? And the question that always comes back is, what if we keep a human in the loop? Let's keep a human in the loop to make all the decisions. Either by removing automations or by having automations that always rely on a human in the loop. And then I come to the third and final case, and that's this situation of automation bias. And automation bias is when your automation system or a computer says something, then the humans have a tendency to believe that it's true, because a computer is more often right than a human is. It's easier to trust a computer than to trust your own senses. And that's really weird if you work with computers a lot, but it's something that really happens. And if you want to hear a horrible story, ask any of the Dutch people here about the benefit scandal, which is also something about automation bias. But that's not my case today. My case today is this one. And this is in here mainly to prove that it's not just Boeing 737s that goes down. But it's also, this is the Everglades crash. This is the incident back in 1972 that set up the entire field of study about automation risks. And in this case, it was one of the first aircraft automation systems. It's called an autopilot. And you set it to a specific course and altitude, and it'll try to maintain that. That's all it does. It's a very, very simple mechanical system. And in this specific case, the system was telling the pilots that everything was fine. It was set to 2,000 feet, so that's great altitude. Nothing to worry about. So the pilots were a bit distracted about some other alarms, unrelated. They weren't paying a lot of attention. And at a certain point, there was a discussion in the cockpit. Our altitude's still right. Yeah, the autopilot's on. We're on 2,000 feet, right? Well, wrong. They weren't. And they crashed into the swamp. So, in summary, no, this is not what I want you to take away from this. I don't think this is going to be true. I don't think that we'll automate ourselves into oblivion. That's not going to be true. But there are a couple of things that we need to do as engineers when we're developing automation, and we're developing automation that is sophisticated enough to truly run our systems for us. There are a couple of things we can learn that the aircraft industry learns through investigating all those automation incidents, and we might be able to put them in our line of work. And one of them is the focus on situational awareness. For pilots in a cockpit, it's very, very, very critical that they always know what's going on. For us as engineers, it's always very critical that we know what automations are running in our system. And that's one of the reasons that I always advocate against having a separate automation team and a separate operations team. Because when you have one team writing automation and then throwing them over the wall to the operations team, that's a recipe for disaster. So if you have such a situation, please, please, please try to have your operators write the automation. Or at least train them properly on it. And the other one is don't undervalue the humans. So I got one case in it, which is not a crash or not one with tragic loss of life. Incidentally, this is not a Boeing, not related. But probably AI would not have been able to land this plane. This plane had a catastrophic loss of power, both engines out, and the pilot managed to land it safely on the Hudson. I don't think the Hudson has been classified in the AI model as a proper landing surface. So probably AI would not have been able to do it and would have tried to reach an airfield and failed. We don't know. So let me summarize this in paraphrasing a famous Dutch slogan. It's okay to automate, but please be aware of what you're doing.
Thank you, Robin. I can imagine there are a few questions. Maybe people are now confused. What should I do? Should I automate? Should I not automate?
Well, let me start with 2 disclaimers. One is I have oversimplified a lot of the aircraft incidents for the case of narrative. So don't pin me on that. I forgot the second one.
You oversimplified.
Oh, yeah. No, wait. And if you have any questions to ask about AI, I have just given my personal opinion on it, and any questions are properly addressed to Bertie Bert. Thank you.
I see that at the microphone we have somebody who is, well, the master of oversimplification, Mr. Peter Lexis.
So they tell me. What are the signs of having automated too much?
What are the signs of having automation too much? I think that whenever you have an automation running in your system that you don't know is there, then that's a red flag. And it's hard to know if there's an automation that's not there. But let me turn it around. At any point, when you're responsible for a system, you should know whatever automations are running on the system.
And if you're not, then you either need to read the documentation or write the documentation, I guess.
If not, you're not really in control. And that's also not just automation, but if you're having a network and you don't know how it works and you're responsible for its day-to-day operation, figure out how it works.
Hi. My question is about automation bias. Basically, how do we avoid it?
Yeah, that's a very good one. How do you avoid any biases? That's just more a psychological question than a technical question, I'm afraid. I think being aware of that is there is the first step. And always be critical of your own reactions, your own thought processes. And that's easy to say and hard to do, but there's no silver bullet here.
Yeah, but that's not really a recipe, right?
Yeah. But I think that's true for any biases. There's no solution for any biases. The only thing you can do is try to be aware of them and act on that awareness.
Okay, I'll leave it like that. Thanks.
That's all I can do for you, sorry.
Thank you again, Robin. Now, I seem to have developed a habit today of stealing people's own introductions. For the next talk, I won't be doing that because it will be about the Rpki HSM. Well, I know 1 or 2 things about Rpki. I do not know many things about HSMs. I believe they are hardware security modules. Oh, now I'm doing it again. No. I will wait. I will not introduce any further without just saying this is Ties de Kok, and he will tell us about Rpki HSMs.
Yeah, and after this kind of eloquent comment on Kubernetes, it's kind of a boring topic, I'm afraid. But let's see what you guys think about it. And I cannot talk about Rpki without introducing it a little bit. The structure, and then we'll go into some more details of how we use HSMs there, and hopefully some nice anecdotes if I manage to weave them in. So first of all, what's the resource public key infrastructure, and why was it done? I think everybody here in the room knows that BGP is a flooding protocol for routing data that's based on trust. A network can send updates. If they do not get filtered, they might get accepted if they're the best option, and if they're the best option, they go further. And that way, mistakes can spread, and also, mistakes can spread, and also some attacks can spread. And with the Rpki that is currently deployed, operational mistakes of typing the wrong prefix length get filtered pretty well, and some other attacks get a bit harder. And the other part of Rpki that you guys probably know, that you all probably know, is that it's an X509 certificate-based system with a root of trust at the regional internet registries. The regional internet registries have a root certificate, which is a certificate that's signed by its own public key, Below that, there's multiple layers of certificates. And in the end, there are Rpki signed objects. The root certificates are the certificates of which the public key is the trust anchor locator. That's in the validation software. Below that, there are certificates that are just intermediates for the operation of the CA. In the end, at the RIPE-NCC, the members have their certificates, which contain their resources. And each layer of certificates below the top one is signed by the certificate above. And finally, there are Rpki objects, one of which is, and for me the most important one, is the manifest. It's an object that prevents replay attacks and withholding some objects. And this is an example of a cryptographic message syntax signed object, which is a binary blob with, in addition, another X509 certificate that contains the validity period and the resources that apply to that object. And that's signed by the CA certificate above. And there's more stuff, you've heard about it. I think this has been taught here many, many times, this intro. So Rpki to RIPE-NCC is done by one team, where we develop the CA software, we maintain the infrastructure, we operate the offline and the online CA, and I'll tell more about those later. We're on call. I'm on call right now. I hope it doesn't beep. I'll jinx it. And we run these layers of certification authorities, and we use two hardware security modules there. One that's held offline, so it's a USB HSM with a laptop. They go in a seal bag together. They sit in a vault, and that's the one that we sign the long-lived things with the Trust Anchor certificate, and every 90 days we take them out. And then there's the online hardware security module, where if you request a ROA to be signed, your public key is loaded from the database into that hardware security module. Your certificate is used, an identity certificate is generated, and that's signed by your key, and your object is made, etc. So we have these two environments, and they're set up in a different way. And one of the keys is a key we basically cannot roll because it's stuck in this software that's deployed worldwide. So we make this one extremely secure, hard to tamper with. For example, the security vault, that's what the vendor calls the configuration for the HSM, is guarded with a quorum of little smart cards to load data in the HSM or to enable new cards. And you need 3 out of 5 cards to do anything. And if you want to sign something with this HSM, you need to have people from another group of cards. In contrast, the online environment is the HSM that contains all the certificates for the members, the intermediate certificates. So it has around 20,000, close to 21,000 certification CA certificates, and a lower number of manifests because some people do not use hosted Rpki, but they use delegated Rpki. And yeah, I had to prove that I got those numbers for real because 21,000 is quite a few, and people really use this in production. So when I started at the RIPE-NCC, it was in the year when people suddenly started to use Rpki in production, and our stuff broke, and it was stressful to run that. These manifests are objects that prevent replay attacks, and it basically means that you cannot serve the same objects again to a validator, and that it would take these objects. That's because they contain a timer, they contain a counter, and also they contain a time window for which they are valid. And when we make these objects, we sign them for a period of 24 hours, and after 16 hours we replace them. That means that when there's an operational problem with these hardware security modules, which basically are one who servers with a secure card in there, we have 16 hours to fix it, or it becomes very highly visible. And this is a nice picture from a data center in Amsterdam at a very late evening in June after a double hardware failure, which turned out to be a software bug instead of a hardware failure, but we only found it out after replacing the hardware. That was a good night. These systems have evolved over time, like what we use now are these, I've just mentioned these one-use servers, but what they started with before I was there were these PCI Express hardware security modules, and I included this to really show what the hardware security module really is. It's basically a highly certified PCI Express card with a lot of potting material on there, so you cannot tamper with it. That does some crypto in there. And it's connected to a smart card reader somehow. Back then with a DB9 port, but now In the more modern ones, there's a card reader, not on the photo of this one. On the edge, on the right edge, you see that there's a card slot. And you use the cards to authorize operations on these devices. So, okay, PCI Express generation really has to be in the server. Newer generation, network devices, you get a kind of crazy setup where your application runs on a server. And then it uses either PKCS 11, which you probably have heard of by name only, or another cryptography API to talk to a local daemon on the server. That daemon has a connection to the hardware security, to a daemon that's running on the one-use server containing the hardware security module, and the crypto traffic gets tunneled from this local daemon to the network device, to the hardware module on there, and that's all one trusted path. And honestly, the details are probably standardized by FIPS. I know they are standardized by FIPS. FIPS points at an ISO standard, and that means that I couldn't read it because I don't have that one. What is fun about these ones is that this one has its Unbroken LED lit up at the left, and that these are actually OpenBSD devices that are out there in the wild and that people run in production. But with the newer ones that we're using right now, they switched to Linux plus the GR security patches. They also claim to use containerization. I don't know how. I think it's for running custom applications inside the hardware security module, really stuff. But what's kind of cool there is that you can fully remote manage them if you want. And that we managed to run these in production on an IPv6 only setup with only one bug that we hit, which was that NTP didn't work as intended, which honestly was not the worst bug we could have hit. As I mentioned, these things are quite redundant. So the local daemon connects to both HSMs, fully redundant, comes with interesting failure modes as well, such as software bugs such as a memory leak, still affecting both HSMs, causing that data center visit that I alluded to earlier. And you can manage these things remotely pretty well, which is especially nice in development. So you use this card with a card reader on your laptop and some SSH tunneling to have a secure connection between your card and the module. You can do everything remotely. You can do the setup of the device remotely using its configuration server and just a telnet serial console for initial setup. So I still live in Enschede and I could do this from home while the things were in Amsterdam, which was nice. Then I've become a huge fan of monitoring and alerting because Rpki shit is kind of complicated and brittle, and we needed to really understand what was happening. It's a standard stack where we also have a lot of application metrics, and I had to learn SNMP a little bit to set up SNMP exporter to get the metrics from the HSMs. So after the fact, with the second crash, we could reconstruct that it was a memory leak that caused the crash. It's always easier to know that you need to find a cause for a crash once it happened. And we spent a lot of time there with these devices, setting them up, configuring it, babysitting our pets, because these devices generally are pets. And they work really well. They're highly certified. You don't know the standards. You have to trust the box. You have to trust the vendor. And honestly, not many bugs in them. But hardware does fail, and especially configurations fail. And it means that if you visit a data center, you do a tiny change there. 5 minutes later, you get paged outside the data center. You have to do a fix right there in the field. Actually, good memory. Yeah, this is the main thing I wanted to share about working with these black boxes.
Are there any questions for Thies about these magic black boxes?
Yeah. Is the process being audited, for example, for the key ceremonies, publicly?
Yeah, publicly. Oh, that's a good one. The team recently got their ISAI 3000 Type 1, Natalie, correct me if I'm wrong, a statement from the auditor, which the members can request from the RIPE NCC, so you can see what controls there are and what we do. And for example, this offline signing process, we documented in a blog post, documented at the bottom of a blog post. And yeah, we really try to, we rely on the trust of the community, so we really try to be transparent there.
Yeah.
That's also why we can show this here.
Yeah, all right. Yeah, because DNSSEC, for example, the routines are being publicly observable. That could maybe be an improvement because it's for the entire internet. But thanks.
Yeah, thanks for the question.
Yeah.
Nick, are you want to ask for a ride home because you're from Enschede too?
You can ride with me. My car is near here, so Enschede. But no, my question is, I run a hobby network aside from a network that I professionally run, and I was wondering how much do these HSMs cost if I want to implement such a system for my hobby network? I think it really needs it.
I think you can, the beauty of these professional HSMs is how you can do key management. Like you can do key management with these smart cards, so it's really, and you get a highly certified process of how you do this. There's a lot of controls, you know it works well. If you just don't want to lose your key, I think a YubiKey, anything that implements PKCS 11, effectively it can be a quite good HSM. So the secure element in your computer, the TPM chip, a YubiKey, should all work, technically.
Oh, that's interesting. So I could just put a Raspberry Pi on top of my single server and put a YubiKey in there, and then I have a professional HSM.
Yeah.
Cool. Thank you.
There is also a question from a remote participant.
Well, this time it's not a remote participant either.
Oh.
But yeah, it's still a question. What happens if the offline unit fails? Is that a single point of failure?
It's a really fun question. So the offline unit is, because this almost we had the feeling this was happening, so it's close to my heart. The offline unit luckily is only needed every 90 days, and you have 2 layers of cards protecting it. So day to day, every 3 months, we need 3 out of 10 people to be there to use the current hardware security module. If the device fails, we need to add a new hardware security module to the security world. So that's terminology for enabling a new HSM to use the keys. And in that situation, we need 3 out of another set of 5 cards. If we don't have 3 out of those 5 cards, it will be a bit annoying.
Okay, thank you.
All right, thank you. I have one request from for Thies myself, and it is please do not forget your card. Thank you, Thies.
It's a testing one, and also all the screenshots and things I showed are from the testing devices or decommissioned stuff.
All right. There is one final presentation for today before we start the quiz, and I think this is a very interesting story, especially for people who have followed the whole development on the IRC channel a while ago. An interesting problem occurred in a network infrastructure not so very far away. And Frank van Vliet is here to tell us all about it. Yes. Take it away.
Okay, thank you. So, good afternoon. I hope you're ready for a challenge, because I will tell you the story in a way that you can think together with me, hey, what would I have done in this case? If you see the data, you can make your own mind up, well, oh, this could be the problem. And then later on IRC, you can say, well, Frank, I already knew what it was at slide 3. Yeah? So, to tell you this story about the bit flipping, it helps to know a little bit on what we do and how the network works, so that comes into play about how we actually experienced an issue. So what we do at Certified Secure, we do computer security training. We train engineers how to do computer security by having them hack into my systems. If you can hack into my systems, with a little bit of help, then you know the problem of security, and then you can look at your own systems and think, oh, I need to make some changes. For this, we have hundreds of challenges, and each challenge consists of multiple virtual machines. And they break all the time because literally we're giving away shells and such on those systems. And yeah, people are hacking it, it will break. So for that we have something that is testing, but it's different testing than what most developers do. Instead of looking at the load and the disk space and those kind of things, what we do is we run a browser that actually solves the challenge by logging in, doing all the steps from the endpoint. So we mimic all the actions of an actual user, all the way until you get the green 100% pop-up that shows you, yeah, you've completed the challenge. We do this for all the challenges continuously from some Selenium farm. And if that fails, and then we get into the autonomous systems from the previous talk, if that fails, it will automatically reboot all the virtual machines that are associated. If that then still fails the test case, it will restore them all to a known good backup. Run the test again. If that fails, it will reinstall all the virtual machines from Git. Run the test again. If that fails, then I get a call, or whoever is on call. And to understand that bit of the story, so on call, I think many of you are on call regularly, and I used to have a ringtone that was like a nuclear alarm. That was not nice, middle of the night. So now we've switched it. Let's see, here you go. Let's hear it. It's the sad trombone. The good news about this is sad trombone is much better, and it tells you exactly what's happening. So that's my tip for everybody. Use the sad trombone. Even now, if I'm at home and I drop a glass of tea, then one of my kids will be from the other side of the room like, whap, 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 sing to me. So the story starts here. Think together with me. As Bert has predicted, at 3 a.m. on a Wednesday night, literally 3 a.m. on a Wednesday night, I was awoken to an orchestra of sad trombones. Not one, a whole orchestra of sad trombones. That's not what you want to hear in the middle of the night, even if you're not on call. That's not something that's nice. So things are bad, and of course you log into your systems and you try to figure out, okay, something is wrong, let's investigate. And this is where all the graphs are useful. You look at the network traffic, oh, fine. CPU load everywhere, fine. Disk space everywhere, fine. No issues, even worse. I can, of course, run those tests myself. So if there was a challenge that was failing, I would run that test case again, and it would be fine. But then another one would be failing. Okay, let me run the other one. Oh, now it's fine. And then another one. And it was one of those tricky problems. So that's not good. And the starting point might be the most difficult thing. You need a little bit that you can pull that thread and do your investigation. You need something. You cannot do, random things break. I don't know. So I was looking, and no disk errors, and nothing hardware related. At some point I saw that one of our load balancers had some health check failures. So if you have a load balancer, it is on TCP level, it doesn't really matter. But it will every second check if the backend is alive. So if you have 140 errors in an hour, that means that a small percentage of those health checks were failing. Didn't know if this was the issue, but at least it's something wrong. But I think many of you know this problem. If you start investigating some problem, you might find something that's wrong. Turns out to be completely unrelated. So then you chase that, and yes, it is still wrong. But I did not know at this moment, is this the issue? So, okay, let's pull this thread. Let's have a look. How do I replicate this error? Well, if it's a connection to some backend, how about I just loop and do the connection to the backend, right? Loop. Anyway, okay, hang. And then okay. Sometimes it would hang for a few seconds. Interesting. I have no idea what it is. I would understand if it always works. I understand if it never works. But randomly sometime, that's bad. So I investigate and I look at the firewall. And look at the log files. And I saw some errors there, drop packets. So think for yourself, what's the logical next step? It's going to be a PCAP, right? At least for me. Yeah, you can say on IC, Frank, of course, it's completely different. But what I did, look at PCAP. So look at this. This is one connection that hanged. I'm going to give you a few seconds to look at it. Think for yourself. Do you see the issue? Yes, there is an issue. It would be funny. Yeah, there was no issue here. There is an issue. And you will see it there. 2 packets. And you can see from the timestamps, there's 5 seconds between them. But from this PCAP, they look identical. But if you know, exactly, retry. But if you know about TCP, the retry should have been 1 second. And then 2 seconds, and then 4 seconds. But this was 6 seconds. Weird. Something is wrong. We know there's something wrong. I looked at my log files, and the firewall said drop packet. That was the packet that was dropped. But if you look at the firewall, at least on IP tables, it is really weird if it drops a packet in the middle of a connection. It's very normal to drop the packet at the beginning. I'm not liking this connection. But as most of you will have, the first line you have is state, related, established, we accept. And then we only focus on the new connections. This is you put this one on top, so it's the first one to go. So I did not understand why is the first packet dropped and the second packet is accepted. What's the difference? Why? Looking more, and then I thought, well, it has to be something with the state engine. Turns out you can add some debug logging to add some debugging of the state engine. Sure. So I enabled that, and yes, I see this. So the connection tracker, state engine, finds out bad checksum. Oh, well, that would explain why the firewall is dropping the packet. And then the other packet, 6 seconds later, does not have a bad checksum. This was, now, I think it was already 9 a.m. It's going to be one of those days, right? This is not looking very good for me at this moment. And especially since this was between 2 different locations. So I needed to figure out, is it me or is it not me? It's a very important distinction. Think for this for a moment. Would you like it to be you or would you like it to be not you? I prefer it to be me because then I can fix it. But we don't know. So we have 2 different locations. What do you do if there's a checksum? You start a PCAP on one location, see the packet going out. You do a PCAP on the other location, see the packet coming in, and you play spot the difference. Yeah? So far, making sense? At least to me, this was logical. We're now at 1 o'clock in the afternoon. So got the PCAP on site A, site B, sending it to site A, receiving it, 2 PCAPs. So send at B is on the left side, received at A is on the right side. Vimdiff, very nice tool, because otherwise you would be looking at a very long presentation here. Vimdiff tells me exactly something is wrong. And I can see from the red, we send a 1 and we receive a 0. Everything else was identical. But if in the middle of this packet you change a 1 to a 0, then obviously the TCP checksum header field is going to fail. Okay. It is not me. The furthest part that I sent it out, I sent it out correctly. I receive it, it's wrong. Something in the middle. But in the middle is the internet. It's going to be a great debugging session, this. I could at this moment send a ticket to our data center. We could send a ticket, dear data center, this is the data center of where we sent it, that is location B. Hey, dear data center people, someone is flipping bits in some of the packets, please fix, love, Frank. That's going to be a great ticket, can you imagine? You get this ticket, now what? And of course you could say, well, since I have determined it is not me, let's leave it at this, but, well, you all know how the world works. It's not gonna happen easily. They're not gonna jump on this, oh, we're gonna put all our resources in this. So I wanted to do a bit more investigation. And where do you start? At the IRC of Nlnog. This sounded to me like the best place to get some insight, because I had never seen this behavior. Some of you may have seen the behavior, but I had never seen it. You send a packet on one end, you receive it on the other end, and some bit was flipped. That made no sense to me, and I had no idea why it would happen on some packets, but not all of them, some connections. And to make things worse, normally with TCP you would have a retransmission, right, within a second. The retransmission would also have a bit flip at a different place. So that's why my testing would fail, because it would hang too long. The challenges would not be completed quickly enough. But sometimes the connection, I was sending like gigabytes of data, no bit flips. And then I do one other connection, and I have bit flips, and in the retransmission I have bit flips. Made no sense to me. So I need help. Nlnog, wonderful place. And yes, I am Haakjes on IRC. Hello, everybody. Yeah, now you know who I am. So I got a lot of help, a lot of insight. Some people actually called out the issue already, like, okay, I think it's going to be this and this. But obviously, one of the problems is, where is the issue? Right? We need more data. And for this, think for just a moment, how would you continue this? You can now send another ticket, but it's not going to help. So I decided it would be best to make it easily testable. So make a script so we can show that the problem exists. But how do you show that the problem exists? Well, what you could do, if you have HTTP, you should be like, blah, HTTP. We do HTTPS. HTTPS much better. Yeah? So if you send an HTTP request, you get a redirect to HTTPS. So if I go to a server, I call it B. It would be a bit too confusing otherwise on this slide. And I say, I want to go on HTTP to /AAA, lots of A's. Then the server was going to respond, please go to the HTTPS version and put in the path AAA. And now I know that the server sends to me a whole bunch of A's, and I can see if I actually receive A's or if one of the bits is flipped in the response. Because now I have a known response from the server, and I can do this to servers of other people. And that's helpful because I already know that my servers have the issue, but I wanted to know, is it me or more, not me, yeah. Just me or not. So if you then look at the response, and you have to look with PCAPs, with TCP dump, because at a TCP level, if you do curl will send you the response, but then the kernel is already going to drop the packets with the broken checksums, or perhaps your network card will drop the packets with hardware offloading. So in this case, I was able to see the bit flips in the PCAP. And I've spoken for just a second. I hope by now you've seen it. It is right there. So for those of you on the IRC channel, I think for many days you have seen pastes of AAA at AAA on the IRC channel. This was it. So we need to now figure out what's going on. We know we have bit flips. I had a few locations. I know from DC2, which used to be Access for All, it's now KPN. That is where the servers were for me. And I had a test point in OVH, and I could see the bit flips between those locations. I had a test point in Trans-IP with a VM. I could see the bit flips in there. I also had a system with A to B internet. And there, no bit flips. Didn't matter how many requests I did. So the bit flips are not always. And if they are not in all the connections. It's going to be a really difficult problem to solve. So let's do a little checklist. Is it just me? I know my servers have this issue. Not to everywhere, but to some locations. I also knew of another customer that was in that same data center. And I could do the test against their website, and I could see the bit flips. So I know it's not just my rack. It could be the entire data center. Possible. But the next step up, could it be even bigger? Could it be the entire of KPN? So how do I test that? I need to find another website that's not in the data center of DC2, but somewhere behind the KPN network. So you go to DNSlytics and you say, well, for this AS number, who are the top websites? Which one would you pick? I know which one I pick. I thought if somebody's flipping the bits of Bert, he might be a bit annoyed with that. It might be a good ally to have. So let's see what happens if we do this against berthub.eu. Bert has multiple uplinks, but since I knew the IP address of the KPN version, I could go directly there and yes, do you see the ad? It's there. Okay, so it's bigger than the data center. We know it is at least bigger than the data center. There's also KPN, bigger network. Could be even bigger. But if we now look at how the things work, some routes have the issue and some routes do not. Next step, better testing. Let's make sure that everybody can run the script and get some data. So we invented bitflipper.sh, a shell script, and everybody was running my shell script. If you don't know me, my background is in penetration testing, hacking, memory corruption. Let's run the shell script from Frank with root access everywhere. Yes, a good plan. So, cool things in this script. It records trace routes, TCP, and ICMP, because those routes could be different. It sends 1,000 HTTP requests. It does the PCAP. It searches for the ad. It will upload all the results to a 6-spaced URL. And then you would have a 6-spaced URL. You put it in the IRC chat, and it's a really easy way to share the data. And this was all the 6-spaced URLs you were seeing for many days in the IRC chat. Yeah. Okay. Would look a bit like this. You have a whole bunch of trace routes. And then you would have the actual packet dumps in there as well, the offending packets. At least we have a very clear problem. So findings so far, we know fiber to the home of KPN has issues. We have also determined it was going to freedom. Everybody was running the script, so we got lots of data points with it. And this was also where we could talk to the KPN people, like, I think something is wrong. We're still not sure where it is, but we're going to need some help here. So they were now also involved. And it's really difficult. Those two routes, both of them had issues. But good luck figuring out which hop has the issue. I couldn't see it from this. And what we need is more data. More data. I don't have to tell you how wonderful the Nlnog ring is. It is amazing. So I got access, and I was able to run the script. And from the 685 nodes at the time, 77 of them found bit flips. Those are them. I was not able to determine a pattern, but obviously KPN was, because they know exactly how things are connected. they now have a pretty good idea of where to look. And this would not have been possible without the Ring network. So we have the community, everybody working on it. We have the Ring actually being used for that. This is wonderful. This is good stuff. This is the good data. So, yeah. By now, we should be able to know the issue. What do we have? We have bit flips on some networks and not on all of them. If a path have bit flips, I could calculate about a percentage and a half of those TCP/UDP connections would have the bit flips. And if that connection would have the bit flips, 5% of the packets would have bit flips. And the bit flips would happen at the same location in the packet, but not all packets would have using the same location. This was enough information to figure it out. Think for a moment. And for KPN, this was their moment. Okay, we're gonna do some A/B testing. We're gonna switch some routes. We're gonna figure it out. But I wanted to make sure that we had a statistical good test that was quick to run, because if you're gonna switch large amounts of traffic, it's better to have a test that is pretty quick and you can trust. So my working theory is this. There is some kind of link aggregation that chooses which port to use based on layer 3 information. That's why some connections would have issues and some do not. I would think that one of those links would have an issue, and I'm thinking bad memory because you write a 1 when you put in the packet, and when you read the packet, it reads a 0. That was my theory at the time. So we made a bit flipper Python, because that's the next level from after shell. And this one, I'm going to give you the percentages as a homework assignment to see later when the slides are online. But basically, we sent 60,000 packets, and we do 400 connections, 150 packets each connection. And I, with a lot of pain in my head, I got to a percentage of a 0.23% chance that we would see no bit flips if there was actually bit flips on this path. I checked with 3 people the statistics, and they all gave different answers. So, okay, this was it. Now, with the friends in KPN, we could do switching. Think of it, we joked about this at the beginning. KPN is going to do a binary search on the network. Okay, they didn't do a binary search, but with this tooling in place, the ring nodes in place, they were able to test from multiple locations. They were able to quickly pinpoint, because they knew which 77 networks were seeing the problems. They already had some ideas of where to go. So you do a binary search, and then finally, the ticket, I did send a ticket at some point, was resolved like this. So for the bit flip issue, there was some packet loss, yes, of 2 weeks. Important things here. The Nlnog community was very active with this issue, and somebody wrote test scripts, and the Nlnog ring node network was used to reproducing the issue. And it was run on so many networks, so many nodes. In the maintenance issue, we were able to, by switching a lot of traffic to redundant path, to isolate it to one single 100 gigabit port between the KPN and the NLIX. They reloaded the line card, problem went away. Yeah. So, yes, one of the links on one of the internet exchanges, it was quite a large link, but of course, on the scale of KPN, you have many of those. That was indeed the issue. Some lessons from this. I really recommend you test your production load from the point of view of the end user, because I would never have detected this issue if I was just looking at ping or things that I know. You have to test for the things you don't know. And one I really recommend, continuously test your production environment from what a user would do, because then you catch all the weirdness. That's my advice. My other advice is use the sad trombone ringtone. Yes. Make the problem repeatable, visible, and impossible to ignore. It is very important. If you have weird stuff, spend the time writing the scripts, because then If you have a community like the Nlnog, they will jump in, and somebody else can verify your scripts. For at least a week and a half, I was convinced I made a typo in my script somewhere because it was so insane. And I think if you have problems like this, without the community, without the Ring network, I don't think it would have been easily fixed. This is such vital infrastructure, so I'm really happy that it exists. So thank you all for that.
Well, Frank, thank you for explaining the Bitflipper story to us in full detail. This has been haunting the community for, more or less 2 weeks.
Yes.
Yeah. And I'm sure there are many people who want to share their experiences or say praise or complain about the holes that they found in your scripts.
Obviously, yeah.
Or something else. I don't know. Go ahead, please.
Hi. Joris, een mooie KPN. I've been doing this work for like 25 years. This was the best ticket ever. Normally it's closer to your first mail. Something's broken, please fix it. Well, this was on the plate. The timing, you were in bad luck because it was right in the middle of the European Football Championship and the Olympic Games. So at KPN we have a network freeze to prevent bad stuff from happening. So it took me a little bit of time to arrange a maintenance window to, well, you want to do what? Shift a few terabits of data left, right, just to see a bit, what, bitflip? But we managed it, and with the reproducible data and Bert's server and all the stuff, the Nlnog ring really came in handy, really handy in this. It would otherwise be very hard to investigate, I think. So thumbs up for the Nlnog ring. Thank you.
Well, thank you for your feedback from the side of KPN as well, Joris. Rinse.
I have a question to you. How many bottles of wine did you send him to thank him? Okay. Just another question. When can we see the ring Bitflipper appear on our Nlnog ring nodes?
So there is a tool called Ring Quality that has been developed. I am developing it. As soon as I'm ready with it, I will put it in the repository, so then hopefully it will be deployed everywhere. It does a bit more than just bit flips, but basically it is doing this amount of connections, this amount of packets, send them back and through, because especially at larger scales, when you have so many redundant paths, you can't do just test over one connection. I think that was the main takeaway, the lesson for me, that you have to test it multiple connections. So that script is written. I just need to figure out how to deploy it without root permissions to do the PCAP stuff on the ring nodes. But we'll figure it out, and it will be on the repository there.
Okay, that's very nice. Thank you.
One last question from Mike.
Not a question, a comment, and not really for you, but it seems like the Nlnog ring is very useful. So I suppose any other tier ones in the room, and I'm here independently, I made my own badge today. Any other tier ones in the room would really benefit, I guess, you'd say, from having an Nlnog machine somewhere.
Please.
Not looking anywhere in particular.
That's a very valid point, because my network is not the biggest one in the country, but every now and then I do have to debug something, and it is always wonderful to find that the network that you want to debug with has a ring node, and it's always a bummer if they don't. So please join.
Yes.
All right, okay. Frank, thank you again.
Thank you.
And we have one more item on the agenda today, and it is time to bring the famous quizmasters onto the stage. You can use the wireless microphones, because I know that you like it.
Ja, daar gaan we uitkomen.
Take.
Hallo.
Now, we have already explained how the quiz will be a little different this year, at least when it comes to the prizes.
And they're all wonderful prizes.
We know the prizes. Nathalie already told everybody. But it's also, the choosing. Whoever comes out first gets to pick the first prize. And the second choice, etc., etc. But one other thing is a bit different than other years. And it is that all the presentations have been put online. And I have heard that some people have already also found the PDF of the quiz online. And I am absolutely sure that there are people who found it, because I heard Rick Astley appear every now and then in the audience. So that was great. While we are loading up Kahoot, I think I need to stretch the time a little bit more.
Yeah, okay. So, who here has never done the Nlnog quiz before? All right, couple of hands. Nice, welcome. Either you didn't stay long enough last time or it's your first time, so welcome. We're going to use Kahoot. Instructions will appear on the screen shortly, as soon as Peter figures out how to get them there. You click start. Okay, there we go. So you can either get the app. Hey!
That's not me. That's not me.
If you want, you can use wireless.
Yeah, that's better. Oh, we are on screen now.
Yes, so
Niels,
get the app.
There is
or
no
go to
quiz PDF in Basing C.
No, there's not. So either go to the get the app or go to the site, punch in the game pin, and you're in. So what's going to happen is there will be questions on the screen. You will have 4 answers. One of them or more of them might be correct. The quicker you press the right answer, the more points you get. If you have the most points in the end, you win.
If more than one of the answers are correct, you only need to pick one.
Yes. And that's it. Where's the music?
I don't know.
Because Kahoot usually has really fun music. Hey! There we go. And we're not doing any interpretive dancing this year. Sorry. It's the hips, we're old. That happens.
Is this too loud?
No, it's fine. This is my jam.
Oh, they control it anyway. Bitflip Chris.
Excellent. All right, so I know we have about 230 people here, so we'll just give it another 30 seconds or a minute.
Anybody having trouble?
I mean, it's IT. I mean, how many nerds do you need? How many nerds do you need?
4 to solve a bitflip problem.
Yeah. Well, at least 27.
Yeah.
Right.
How many people are called physics now?
There are just many Frisian people.
Right.
That's not what happens.
Also, I had a couple of teenagers help me with some of the questions, so good luck. They're also watching, so behave.
No promises. It's pretty stable.
Is anybody not joined yet that wants to play?
I don't see any hands.
No hands.
All right. So, are we ready? All right.
Yay.
Then we're off.
We are at work.
Oh. I'm not getting paid. Are you getting paid?
I am. We're getting 20 questions. Question 1.
What is the name of the dentist at 42 Wallaby Way in Sydney? I think I know, but I've seen the answers. This was a teenager question, by the way.
Sorry?
Was this a teenager question?
No.
No.
So are you. The comment was the movie is old. Yes. The dentist at 42 Wallaby Way, Sydney, in the film Finding Nemo, is P. Sherman, a pun on fisherman.
Indeed. It was almost a guess for most of the people.
Looks that way, yes. Let's see how you did. Nice. Nice, Jorgos, nice.
I think you get 1,000 points if you're like on the clock.
Yeah. Question 2. Which of these Ubuntu version numbers actually existed? So as most people might, what?
I don't think this animal has ever been an Ubuntu mascot.
This animal is the animal that goes with the right answer.
But
This is a Dapper Drake. A drake is a male duck.
Oh, I was expecting it to be a dragon.
Ah.
Wow.
Yeah, so 404 never existed because 410 was the first release ever.
Warty Warthog, for those still in the know.
Yeah, that might be right.
I know it's right.
And then every Ubuntu release ever has ended in 0.04 or 0.10, except 6, which was late.
Yes, I don't remember why. But
it was the first one that did AMD 64, but I don't know if that's the reason. Anyway.
Next one.
They all picked green. That's the best guess if you don't know.
Last year it was red, so remember. Oh. 100% new list. Perfect.
Kneus is the highest climber. That's a weird name for that. Number 3.
Which IP address is not in the assigned documentation space?
Because it is
slow.
Because it is BT owned.
Perhaps.
No, the one you picked for that is BT owned.
Oh, I just did it like this. Whoa, people are slow. Unexpectedly so. Wow.
Please explain.
Yeah, all of them are assigned documentation space except for the yellow one. So why don't you pick the right one?
I guess these are the less known ones.
Yes, yes, of
19202 or 2008, 2001 DB8.
Yes,
yeah.
Of course I picked the hard ones.
Of course. Well done.
This is the merciless quiz, not the easy quiz. Oh.
I think that's the Cyber Teeners. You're the first one I've seen on the screen twice now. Well done. Number 4. In Gravity Falls, what kind of being is Bill Cipher considered to be? This question was donated by one of my teenagers.
I know I've seen it, I just don't remember. That stuff was too trippy.
That stuff is too?
Trippy.
Gravity Falls
Yes.
is trippy. Yeah, it's good,
very
good stuff.
Recommended though, recommended.
Oh,
okay.
Oh,
That's pretty
yes,
good.
well
Pretty
done.
good. Well done. Well done. But this is some deep lore, though.
Yes. Yeah. This kid sent me 7 questions about this show to pick from.
Wow.
All about Bill Cipher.
Yes, because his name is Cipher.
Ja.
Oh,
Mark, dat gaat lekker. We'll get you soon.
DNS packet compression is done with what?
No, not with what.
No. Well, it takes more watts to decompress.
There's some pretty good free clip art in Kahoot these days.
Yes, it's very nice.
Or stock photos, I should say.
Oh.
Oh no.
Oh no.
Oh.
Okay, so you're probably layer 3 and below.
That's fair.
Yeah, it's okay. We all have a problem.
To you, I am the protocol overhead.
Yeah.
Oh. Well, we'll get Mark soon. Number 6.
Also climbing.
According to the Steam hardware survey of September of this year, what is the most common desktop resolution? So I'm wondering, is that the same as the Steam Deck resolution?
No, it's
Don't
not.
answer that.
No, because it's not on here.
Oh.
The Steam Deck resolution is 720p.
720?
Yes.
Oh, right, just like Switch.
Yes.
Nintendo Switch, not
Yes, not
HPE or
not
Juniper.
No, those have like tiny screens.
Yeah.
Yep.
Decent. Yep. Those blue people are optimistic or too rich.
Yes, 14.4p master race.
Okay.
Okay. Anything can happen. We're at question number 7.
Yeah,
so.
and I think Andre won before as well. So
yeah, Andre's dangerous. What is the final stable decay product of Americanium-241 found in smoke detectors after its full decay chain? This decay chain takes a couple of million years.
So, fun fact, you made a typo when you wrote this question.
I did?
And you just read it like the typo was still there.
Nice. I'm really good at those things. It worked in my head.
Yeah. Explain.
Well, so if
Bert?
So I'm not a nuclear engineer, but if you have an unstable isotope, it will decay. It will decay a lot of times because it will decay into different things. But in the end, there is a very stable element, and in this case, that's thallium-205. This is the neptunium chain. You also have the uranium chain, and that one ends at lead, I believe. I'm sorry.
Cool.
We need to have a really hard question.
You're not sorry.
No, I'm not sorry.
So I think, Mark, you got this one wrong, and you're still on top.
Nice. It's probably the streaky head. Or are we doing streaks?
No, we're not.
Oh.
How many strings does a full-size piano have, roughly? The photo helps. Look at it.
How does it help? Explain. Explain the piano.
The piano has 88 keys.
Okay. Thank you.
Did that help?
Definitely.
Okay.
So very few piano players here in the audience.
Well, actually, based on 88 keys and the picture helping, green is quite an obvious choice.
No, green was always the best choice.
Yes.
Except that it isn't.
No. Anyway, what happens here is that in a piano, most keys will trigger 2 or 3 strings, which turns out to add up to a total of roughly 230 in most brands.
This is also why getting it tuned is really expensive.
And hard.
Also. Hey,
Andre.
Well done.
Well done.
What was AppArmor's original name until 2005?
Only one of these answers is unrelated.
Yes.
The other 2 wrong ones are
related, but different. It's the same, but not the same.
Yeah.
Wow.
So if I recall correctly, before Novell bought it, it was called Subdomain. And Immunix owned it. It's something like that, but there's a very good story on Wikipedia.
This will hopefully change up the list. Not as much as we thought.
Yeah. Our original number 1 is back at 3.
Very good.
DevNull. Okay. What port number is reserved for and used by IPP, the Internet Printing Protocol, made famous by COPS?
Very nice piece of software, I heard. Very stable nowadays. Also, no security holes whatsoever.
Not in a default install.
No, exactly. It's very good. Definitely not a 9.9.
I stole this comic from the Honest Networker.
People.
This is just mostly dice work, except for 10.
Okay. But it was green, though.
I guess nobody followed the advice to filter that port last month.
But again, it's overhead for these people.
Yeah.
Okay.
Exciting.
Very good.
This is close enough.
Yes. Oh, yeah. Anything can happen. We're halfway.
And in fact, if they haven't picked the same price, doesn't matter at all.
Nope. What was Eric Bij's favorite sport?
I want to thank Job Snijders for suggesting this and sending me that photo. Eric is a second.
Oh, that's a wonderful picture.
The guy on the right is in here as well.
Yes.
There's 2 valid answers here. Yes, well done.
Well done. Now it's up to who was fastest.
Yeah.
Ooh.
Okay. Exciting times.
Yes.
Oh, we do have streaks. Didn't know. Three players have reached answer streak 3. All right. Number 12.
The furthest point in an orbit, the apoapsis around the Earth, is called the apogee. How is this point called when you're orbiting the moon?
I learned a lot from fact-checking this question.
Yes.
Like the G in apogee comes from Gaia.
Yes. And there is no Apotera. Somehow they didn't use the Latin name.
No.
You know how you can recognize fantasy and science fiction, right?
Well,
if they call it Gaia, it's fantasy.
Oh, right, yeah. Yeah, so I would have picked Apoluna from Luna.
Yeah,
but
which
apparently there are 3 names for the moon they derive these things for, and they are all valid, maybe even equally valid.
They are all equally valid. Fun fact, during the Apollo missions, they used the Apocynthian one.
And Apo Orion was Mars, right?
Yes, Apo Orion is around Mars.
An orbit around Mars. I hope never to have to do that. Okay, Andre.
Not a lot of good answers here.
No, but this is still quite close.
Yes.
Although yours was gone again. What is the nominal voltage of a CR2022 battery? I almost picked a stock photo of the top.
Oh, that's dumb.
Yes.
It's good that you say only one battery, because if you have multiple, you can get more.
Yeah.
Which is fun. Okay, yeah.
Yeah, that seems right.
I understand all these answers.
These guesses make sense. Except the blue.
And the 9.
Yeah. Oh.
You can still make it.
Maybe.
Which of these pin numbers are the ground pins on a Raspberry Pi 4 40-pin header?
Is not a Pi 4 specific question.
No.
It should be similar on the 3 and the 2 and most of the 1.
And there are multiple answers, right?
Yes.
Yeah. So you got more than 25%.
Like
if
6
you
or
guess.
7 ground pins on it, and a few of those are in this list. For those who picked yellow, that's how you get fires. Very small electrical fires.
That's a 5-volt pin, right?
Yeah, or maybe 3, but yeah.
Yeah.
All right.
Well done.
Ooh, snap.
Ooh.
Oh, Luke's climbing up.
Yeah. It's close, but
it's
still
close.
Winnable. Due to gravitational time dilation, time passes faster on the moon than here. How much faster?
What's a furlong?
I don't know. I know a fortnight is 2 weeks.
Yeah.
And a bad game.
That's a different spelling.
Yes.
They say it's an epic game.
Yes, I heard as much as well. Wow, well done.
Yeah, not bad. So it turns out there's been a couple of good articles about this recently, that this matters a lot.
Yes.
Because if you do time measurements here and there, and you use those to position somebody on there, you might just drop them off 60 kilometers or whatever.
In a day.
Off the right spot, yeah.
Also, fun fact, NASA is looking at creating a time zone for the moon. So your TC database is going to be updated in a few years.
Gonna have to invent some new math for that, I'm afraid.
I'm afraid so.
It's Andre's leading by quite a lot now.
Yes. Get your act together, people.
What other ASCII characters can A turn into by exactly 1 bit flip?
But not the answer everybody was expecting.
No, I left that one out.
Yeah, very well. Very
There's
good.
8 candidates. I'm also quite proud of this picture. It's not a stock photo.
Is it the Linux Foundation logo?
No, it's the bit logo.
Oh.
But I flipped it.
Oh, that's really good. That's really good. Also, yellow was not the answer.
Again?
Again.
No, so to get from A to B, you need to go from 4.1 to 4.0 to 4.2. So that doesn't work. And that leaves C and E and 6 other candidates, including, of course, the @ sign.
Yes.
My phone is ringing.
Uh-oh. Is it one of the teenagers?
No.
Okay. Then it's okay. Then you're still doing it well.
Yeah.
Ooh.
Okay, closing again a bit. Or no. 900 points.
But we still have a few questions. So
Yep.
It's possible.
4 left.
What's the HTTP status code for unavailable for legal reasons? I think this was standardized a couple of years ago. Like
Yes.
5-6 years ago.
And the answer is the temperature
at which
depicted.
Yes.
Yes. Heard somebody say Fahrenheit 451.
Yes.
The book by Ray Bradbury about censorship, I guess.
Yeah. I don't know. I couldn't read it. It was all flashes.
Yes.
Okay.
All right. Now what?
Oh.
Okay. Kitty's doing well.
Yeah.
That's Julia, right? In Carmen Sandiego, Season 1, Episode 5, The Duke of Caper. Which Dutch artist artworks were stolen and returned?
I have not seen this episode.
The photo
this
is
also this is also the new series. Nobody watches that.
The photo is an honest hint.
It
What do
is.
you mean the new series?
Well, they have like the old series and the new series.
Oh, they have like the computer games and the series.
Oh.
This is the series. Yeah, decent guesses.
Yeah.
I would not have done better.
No, definitely not.
But that photo was from the episode, and there was a modified Vermeer.
Oh.
1,000 points. Well,
One
996.
question. Two questions.
Two
to go.
questions left.
All right.
Is there a war in Ba Sing Se?
I also did not know this answer. I had to look up the reference.
Okay. I wrote this one inspired by the teenagers.
I definitely understand.
This meme has been reused for a few other things, including some about claims from Elon Musk in the recent years. I've decided that all answers are valid because this is politically charged in the Avatar: The Last Airbender universe.
Ah.
But the children tell me that the most valid answer is the war is outside Ba Sing Se, what affects Ba Sing Se.
Thank you.
Yeah, you're welcome.
Did you now spoil everything?
No.
Okay.
Okay. Andre is just very fast.
Yeah.
All right. One question left.
Yeah.
Which means the top 2 is basically settled.
Yeah, unless Fubar really messes up and Andre really messes up, but I don't expect them to.
You mess up for a negative amount of points.
Well, I mean, get 0 points and then...
Yeah.
But...
Well, right, streaks could help. We'll see, we'll see. Exciting times.
Very much.
Last question.
Which country has the most metal bands per capita?
This band is from the right country. This band is from the right country.
Sure looks that way.
It is also, as I heard somebody just mention, the most metal country, where they just go out in a shirt like this in winter.
Yes, exactly. Well
All right.
done.
Now.
Norway, good guess. Germany, good guess. But yeah, it's Finland.
All right, now for the final results. Oh, there's a podium. This takes forever. Although it's faster in not Firefox.
Number 3, Kitty.
Kitty.
Woo!
Well done.
Well done.
Number 2, Mark. Number 1.
Well, we're pretty sure we
Andre.
know who it is. Andre.
All right, come
well
on
done.
down.
Yeah, can I have all
Julia
3 of
needs
them
to
up
take
front?
a picture first.
Yeah, and all of them up front.
Yeah. All right, there's Andre. Well done.
Yes.
Well done, everybody. Hope
Yeah.
you had fun as well. Congratulations. Now, what's that? Yeah. Now, it's my understanding there are 3 prizes. There is a Steam Deck, a Pi KVM, and a big iFixit toolkit. I pick the toolkit, but I don't get to pick. You get to pick.
Yeah, you get to pick.
Congratulations. What would you like?
Thank you very much. I would take the Steam Deck.
Nice.
Very good choice.
And Mark, what would you pick?
I'll go for the Pi KVM because I want it anyway.
Very good, very good.
Very
Congratulations. Good. And you, Julia, you get the iFixit toolkit, which is awesome.
My housemate asked me to stop buying tools.
Sorry? He wants you to stop.
You did not buy them.
No. This is not buying.
Well, congratulations, all of them.
Yes.
And thank you all for playing.
Enjoy drinks and dinner.
Thank you, Peter and Peter. This was, again, delicious. Wonderful quiz. And yeah, I, for one, cannot believe that this day is already over. It's so fast. Maybe we are on the moon by accident. Time is different.
Very little bit.
Very little bit. Okay. Right. Yeah, well, but this is it, actually. And I just have to, once more, give the microphone to Natalie for the closing words.
Yes.
And then, yeah. Can you believe we are already done?
That flew by. But, all right, I'm standing between you and drinks and more food, so I'm going to make it short. But we do have to thank a few people. First and foremost, I would like to thank all of our speakers. I believe we had an amazing program today. Thank you, speakers. Last year, we opened up an RFP for the first time, so a request for presentations. And this year, we were completely overwhelmed with the amount and the quality of the presentations. It's a steep path, so I'm looking forward to next year. The bar is high. Then I would like to thank our support crew. We have quite a big support crew. People working behind the scenes. For example, Sven and Denise from Global Media Group. Thank you. Then, of course, our crew from Podium Mosaic. Jaap, Ruud from the technicians, Brit from Podium Mosaic itself, Kim for the catering. Thank you very much. And lastly, we also have, of course, the Wi-Fi that works, event infra. We have Anna from the Red Dress Effect. Thank you very much. Peter and Peter for the quiz again. Awesome, thank you. Then I'm going to thank you, our participants. Audience. Audience is not the right word. You were quite involved, all of you, today. We have a record breaking of 8 no-shows today, which basically means the one person that got sick or the other one that couldn't find a babysitter last moment, but all the rest of you are here. Thank you very much for coming. And then there are a few people that worked really, really hard in the last few months. And that is your very own Nlnog board. With Teun, with Cas, with Nick, with Robert, with Niels, and I'm forgetting one. Myself. Thank you. So before I'm going to thank our 27 sponsors again, we tried to organize the New Year's drink already because we were on a roll. And so we tried calling our regular venue for the last 2 years the Rechtbank in Utrecht, but they were closed yesterday, so to be continued. We aim to go for the 3rd Friday in January, as always, and our preferred location is the Rechtbank again, so probably I'm jinxing it now. But yeah, put it in your calendar, 3rd Friday of January in Utrecht. And now, my last final words before we going for drinks and food downstairs until 10, and then we're going to be kicked out. I would like to thank our amazing sponsors, which are KPN, PowerDNS, SpeedIX, Duocast, i3D.net, AM6, Arista, RETN, NLAX, Quansa, OpenBSD Amsterdam, LoanApp, Nokia, Smart Optics, LeaseWeb, Physix Networks, 10IT, Fibering, NTT Data, Solid Optics, AVM, Nexpertise, Telesol, BIT, Genie Networks, Nexonek, and Air Traffic Control Netherlands. Thank you.